Thelma Scott. Okay, well, hopefully she'll return the meeting. What I was saying is that a student mentioned to me that she was getting like email reminders or notifications of a meeting, multiple times in the middle of the night or whatever. And of course, this doesn't seem normal to me, but it is normal. For some bizarre reason, we get these like echoes of meeting notifications that come at sometimes at all times of the day or night. But can I assure everybody, I am never going to try and initiate a meeting at 1 a.m. Never. Our meeting time is 1:15 to 5:35, and some days we will meet constantly from 1:15 to 5:35, and some days I would like to do what we've done a couple of times already, which is, stop at a certain point in time and go, look, it's up to you to can do some lab exercise or to use this remaining time as I'm going to shut my volume down a little. I can hear myself reverberating. All right. Is the volume high enough that everybody can hear me now?
Yeah.
Good. Good. And you can probably turn the volume up on your end. I can hear myself reverberating if the volume is too high. So anyway, just so you know, if you get a meeting notice on Saturday at 3 in the afternoon, it is not me trying to initiate a meeting. It's like an echo of a previous email that has some reason coming back, and I don't know why that is. I try to understand the basic computer stuff, but then the stuff that like borders on the supernatural, I don't know. I have trouble understanding it. But anyway, don't worry that I'm trying to initiate a meeting at that time. I'm not. When I'm going to be initiating a meeting, somewhere between 1 o'clock and 1:15 on any given day, and that's when you should expect it. Oh, sorry, not any given day. Monday, Tuesday, Wednesday, Thursday. I mean, this class meets Monday, Tuesday, Wednesday, Thursday. It doesn't ever meet on Friday. I should be sending out a meeting notice about, let's just say 5 after 1. And most people are already into that routine. I mean, I've got 19 people sitting here today, and there are other people who might join us. I hope they will join us, in the next few minutes or whatever. But no, I'm never going to send out a weird meeting notice at some crazy time. That's just some weird computer artifact or something like that. So anyway, again, thanks for being here. Look, there's no, reason to sugarcoat it. The elephant in the room, I hope there's really not an elephant in here. The elephant in the room is that most of us would probably rather be in a classroom, a normal classroom, doing the normal kind of thing. And the fact that we aren't makes it, unusual, uncomfortable for all of us. I mean, that's equally true for me. We're crossing our fingers and hoping that maybe things will be a little bit different in the fall, where they'll have limited access to labs and all that. But we don't know that now. Some of these plans to do the hybrids in the fall were based on us on sort of the conditions that existed in Tucson in the state of Arizona 2 months ago or a month ago, not right now, where we're one of these COVID hotspots. So most of us are doing what is the right thing to do, which is staying home. And we could, I suppose, just stay home and watch TV and eat bonbons all day long. But instead, people are doing their best to continue their education despite these conditions, because sooner or later, the COVID-19 crisis scenario will fade. Oh, I don't think it's going to fade right away. I mean, I think what it's going to require for it really to fade into the background, something we can tell our kids and grandkids later, is a vaccine. And I don't know, I'm eternally optimistic that there are people out there working on vaccines now for whatever reason, and that we will be able to get vaccinated at some time in the future. And then everybody will feel safe going back into classrooms, etc. And that'll be great. I'm looking forward to that. Well, I hope, and to be honest with you, just between you and me, I hope that what they do is they figure out how to solve the COVID-19 crisis, but then that they immediately figure out how to prevent such a thing from happening in the future, if that's even possible. I'm sure there are plenty of other viruses out there that could cause just as many, personal, social, medical, economic problems as COVID-19. But we need to be vigilant and alert about that. So, as a biologist, I try to understand what's going on with COVID-19. I think the sort of biology of COVID-19, and it is relatively, what I'm saying is the biology of viruses and transmission is relatively well understood. I'm not saying COVID-19 is perfectly understood by any means, but like I said the other day, viruses aren't actually living things. They're these strange robotic replicators. They may have been involved in creating the situation in which life was created on the planet Earth. They may have been involved in that, but they themselves do not have all the characteristics of living things, and so they fall off the list for me. So I have to say, well, they're not alive. They're something. I mean, they are some maybe pre-life. They certainly are. They're driven by a desire to replicate themselves, and that's what they do. I mean, they remind me of some science fiction stuff that I've read about or seen on TV or in the movies, where there are replicators that are just driven to replicate, and that's kind of what viruses are. So anyway, we're going to start talking about life and the characteristics of life pretty soon, and when we do that, we'll talk a little bit about why I throw viruses off the list of living things. I'm not trying to disrespect a virus. I want to be politically correct and not disrespect a virus. But the bottom line is that it just ain't alive by the conventional definitions of what we consider to be living things. So, all right. So, thanks for coming to class. I really appreciate it. We're all doing the best we can, and we'll take it from there. I want to pull up, you know me, I told you before, I'm kind of obsessed with logistics, and I want to pull up today, where this is day 4, July 7th, and a basic agenda for today. I don't post this agenda because it's kind of a work in progress. I sometimes modify it within seconds of beginning the class, but let me just work our way through it and give you time to make some notes about it in your in your notebook. I know that some of my students, whoops, I lost it. Some of my students are pretty new at being students, just at coming to HEMA and taking classes and all that kind of stuff. And so I would strongly advise that, to the best of your ability, you take notes on what I'm saying, because the note-taking process for many people helps to inform their brain that what is going on is important information. And so I'm not going to post this daily agenda. As I said, it's modified sometimes 1 minute before you see it. But here's the plan for today. Number 1 is I have put I've put thought questions up here to still. B through N are, B through N. Sorry, let me pull up the thought question sheet so we can actually look at it. I have it here somewhere. It's not there. Hold on. I'll be right back. Okay,
Oh,
there we
yeah,
go.
sorry. I
I'm
want to
gonna.
let you know real fast that the Alka-Seltzer lab, at least on my end, it doesn't open. Like, it just says error page not found.
Oh, really?
Yeah, it's
Wow.
not
Mine
working.
that too, but then I just went through my Pima and it worked that way just fine.
Oh,
Interesting.
on
Okay.
D2L it won't open, right?
It won't
Yeah, so
open there,
D2L,
but
yeah,
it will
Oh,
D2L
open on
looks
my
fine.
Pima.
yeah. Well, that's part of the reason why I'm trying to sort of co-post things in
Weird.
both places. Okay. But that is odd. I mean, I'm going to just go back and say that when I'm semi new to D2L. As I've freely admitted, I'm working on D2L. I'm doing my best to make progress on D2L. Where am I here? Actually, somewhere I'm here. There I am. I was going to say. So I'm kind of new to D2L. I'm doing my best to, make it work. I'm going to go right now, just out of pure curiosity. I'm assuming everybody can see everything I'm doing here. I'm going to go pure curiosity over to D2L. And this page looks very similar to your page, I'm sure. And I'm going to go down to our course, which is right here. That forest looks nice. Nice, cool forest. Sounds good. Then over here, I'm going to go to content. Let me just check here. I've got. Okay. The reason I said that, I've been trying to arrange things a little bit differently. So here I'm going to assessments. I'm going to assignments. And under the assignments, there's the lab called Alka-Seltzer Science, right? I'm just going to click on it. And because I've set it up as an assignment.
Oh, there. Okay. There
Well,
we go.
but
I didn't realize it was under assignments. My bad.
well, and that's me. I'm looking at it as an assignment right now. I'm clicking on it and I'm trying to see the actual document.
Yeah, I found the document under. Yeah, I just clicked on it under assignments and it works. I didn't
Oh, and
realize
it
it was
did.
there.
It opened up,
Yeah,
right?
it works. It works.
Yeah,
I just
it
printed
works.
it.
It
Yeah.
just wasn't. I guess it just wasn't where the D2L thought it was. I don't know. But yeah,
Here, I'm just
it
gonna.
opens just fine. Okay, cool. So it's
I'm
under
gonna
just
look at it
assignments.
as if I was a student. Assignments.
Yeah. So usually things just like I'm just used to them popping in under content.
Right. Well,
So
that's where I was putting things until somebody said to me, tech person said, "Hey, you should put these under assignments." And so now it looks like, yeah, it's downloading for me.
yeah, and it opened on mine. So I should assume that anything posted is just going to be posted to assignments then.
Yes, unless it's a document. Like if I'm just posting a document that I'd like you to view, then I'm going to post that as just like in the table of contents. But I'm trying, like I said, to get a little bit better at because now what's nice is now I think that because it's an assignment, you can just put it in an assignment Dropbox.
Yeah. Perfect. Yeah.
As opposed to trying to send it to me some other way. And again, I apologize and say that I'm not an expert at D2L, but I think I'm going to get better at it over time. Was somebody trying to make a comment there and I cut them off?
Yes, when I was trying to look at the homework, the one you're just talking about in detail, the one for measurement and using metric to measure.
Yes.
I can't find how to watch the video you were talking about.
Oh, one that's mentioned in there?
Yes.
Okay, so
are you talking about the one like in the document?
Yes, it says in measurements.
So there's an extra space. There's an extra space in the URL. So what you just need to do is just copy it, and then just paste it as in the regular. Here, I will show you in the regular URL. Let me pull that up real fast.
So what that means, let's look, let me see if I can look at, if we can look at that document, which we should be able to. We should be able to look at that document. I'm going to go over. Sorry.
This is right there in the class notes when you start reading the homework description. It says, before starting this homework to something, please watch this video. And I thought there would have been like the URL posted in the homework itself.
Kendall, you can actually copy that one, or you can just type again all those link there, open another cursor, and you can open that just fine.
Here you go. That should be the that should be the proper link. Yeah, that's here. I just put it in chat. That's the right link.
All right. So what you're saying is that somehow when it all got copied over, a space occurred, and believe me, I know full well that one single space like that will make a huge difference. You can't even, you can't even view it under those conditions.
Yeah.
So,
Oops,
I wanted to look at that document right now. I'm sure I can pull it up. Just need a second to do that. Let's see. Not there.
Yeah, it's the link under measuring mass and the link under the graduated cylinder videos. They both have like little spaces after the question mark.
We're going to get it now. Oh. I thought we were going to get it. I thought I had that right there. Sorry. Right back. Oh, that's not. That isn't what I wanted. What I want is metric measuring at home. There we go. Ugh. Okay. I'm going to get there. This is way too complicated for me, but I'm going to figure it out. Okay, so metric measuring at home. So it's measuring mass. I'm going to go down there. There's measuring it. So it's towards the end, right? There we go.
Page 9, I think.
Just want to see that. I would like to see this URL. Ruler. Measure up. I went too far, didn't I? Measuring temperature. Oh, maybe not. I did. It's way up there at the top. There it is. It's this one right here, this YouTube one? Was it this space right there?
Yes. There's a space, the space after the question.
I see.
Yeah. And then and then the graduated cylinder video, there's another space after the question mark on that one as well.
Got the same problem, huh?
Mm-hmm. I just sent both fixed links though into the chat.
Thank you. I just paste and copy them into another Word file so I can watch them later after class.
Yeah.
Yes, great. Now look, I just corrected it right there. That's not going to be posted. I have to post it that way, but thank you for. And you said there was also one in the graduated cylinder issue too, huh?
Yeah.
Wow, that's crazy. Because that, again, that's just how that kind of stuff happens. I don't know. But I can see it right there again, sure enough. A space like that is going to set things off wrong. Well, this may not help us too much now, but it's great to be able to solve these problems. I really appreciate your input, and I apologize when it's not as user-friendly as it should be. I mean, again, I think I mentioned to you that these are labs that have been generated under the time frame of us trying to create these classes right now. At the end of last semester, I'm sure many people remember this, we went home for spring break and we never came back.
Yeah.
And so all we did was we worked on building the stuff for the second half of the semester, because the second half of the semester was staring us in the face. But now we're going back and going, all right, well, we're going to be virtual for a while, so we need to redo everything that's in the beginning part of the semester. And, you put these labs together and, you check them and double check them and proofread them and double proofread them. And I swear I've checked those links, and that's what just seems crazy to me, that somehow that happened. But
we'll just blame it on the computer. Computers are
here's
weird.
the thing. We are going to get through Bio 156, summer session B. We are going to get there, and we are going to somehow figure it out, even with me as your instructor. I guess that's the only nice way to put it. So I'm going to do my best to try and collect all that. I'm going to go back, if it's okay. Believe me, but here's the thing, please. If you have a question, comment, concern, then you've really got two possibilities. You could go up here to the chat line and you could do it. Thank you, Emily, for putting those back in, for putting those in correctly. You can go to the chat line, and hopefully I'm trying to keep my eye on the chat line so I see if there's new chat stuff. Or else, please just activate your microphone and jump on in. There's no way to raise hands in a classroom like this, and so you just have to jump in, and I'm not going to be insulted about it. Believe me, I love answering questions. I like to try and solve problems, and so I would hope you would jump on in and just let me know if there's issues that are like these issues. All right, so I was going to go back to this, and at the same time, look at the thought questions I've got listed here, B through N and X through Z. So here's the thought questions. Take a look at what B through N represents. B through N is all science stuff, all right? And we are going to be working about our bunch on science stuff. And then I jumped all the way over to X through Z because I was thinking that no matter what today, I would like to start talking about the characteristics of living things. And I have to admit, part of that is just because I want to talk about some biology in addition to everything else. And so I could just boom through the entire science PowerPoint today. I might do that. And then if we have time at the end, start working on that. That's why I put X through Z there. But absolutely, if we somehow don't get to that characteristics of life stuff today, then we'll get to it tomorrow for sure. So that's what that is. B through N is all science stuff on the thought question sheet, and X through Z is the very beginning of characteristics of life stuff. Okay, so we did say that this metric measuring at home lab was due today at 5 p.m. And look, here's the thing. I realize people are having issues and problems with this lab. So it's nice to have a deadline and go, look, this is when I'd like to have it. And that is when I'd like to have it. And believe me, a ton of people have sent it to me already. And if you've sent it to me already, please don't stress out that I haven't graded it and recorded it and sent you back comments and all that, because right at this moment, I'm slowly working through that list of materials. So some people may have heard back from me and some people haven't. Most people haven't heard anything back from me. I'm going to be working on that as fast as I can and getting those grades posted. And probably I have to admit a certain percentage of that's going to happen over the weekend when I'm not setting up for class and meeting in class. Okay. But if you are done, then turn it in. If you need a little extra time, don't get extra stressed out about it. Just take your time, do it, and turn it in ASAP, please, okay? Next thing here is lectures 1, 2, and 3 are posted on YouTube. I mean, I think it would be horrifying to have to watch one of these lectures again. But if you miss a class, which would not be good to do, but if you were to miss a class, I've already posted the YouTube recording. I posted on YouTube the recording of the first, second, and third meeting of this class, and I plan to do the same thing. So by the end, there'll be roughly 20 lectures posted there. So I record it, and then afterwards, it takes hours to process it actually, and that may just be because of my internet service or whatever. But once we're done, I have to download that recording, and then I have to upload it. And I'm not joking in saying that that takes 4 or 5 hours to do. I mean, I don't have to do anything. I just have to sit there and watch my computer do the work. But I am posting those in case you want to go back and watch a specific part. You could do it. Or if you were to miss one of these classes, you could go back and watch most of what happened in the class again. So they're posted, and I'm going to continue to do that. I don't know, maybe I may not be necessary for me to continually tell you that, but the best way to search for that is why I put this name, my name like this in bold, Stephen Mackey Bio 156. When you go to YouTube, go to the search line and just put in Stephen Mackey Bio 156, and it should take you to a long list of lectures that are posted on YouTube. Okay, and the top ones should be ours, but there are quite a few there, and so you want to make sure you're not going to watch one that's completely out of sync with us. You want to look for ones that are dated July 2020 for sure. Okay, so they're out there. If somebody wants to reconsult them, they will haunt me for the rest of my life now. But okay, and then I'd like to continue talking about science, the PowerPoint that I've got, and just process of science. I'm hoping to start talking about life and living things today too. Oh yeah, here it is. Quiz 1 is posted and due by noon on Thursday, right? Noon Thursday. That's not 48 hours, but it is close to 48 hours that you have to work on this quiz. And like I said the other day, this is an open note, open book quiz. The only thing that would be dishonorable and a breach of scholastic ethic would be if you were to work on the quiz with somebody else, because you need to do your own work. Otherwise, you're not going to learn what you need to learn, okay? When I make up an exam, and believe me, I've scheduled an exam a week from tomorrow. When I make up an exam, a number of the questions on the exam come straight off of quizzes. Now, one of the things I'm going to do tomorrow is I'm going to actually post the essays that are going to be on the exam. I'm going to post the essays a week in advance. And I'll tell you why. I want you to know what the essays are. I want you to be able to choose the essays you're going to write. I want you to be able to think about the essay, and I want you to generate a really good essay. Now, look, if you've never taken a science class before, can I tell you this is unusual? You may never in your academic career ever find another instructor who gives you the essays a week in advance. But, you know, I've been a student myself for longer than anybody in my class. I mean, I started in college in 1973, well before most of you were even born, right? So I've been a college student a long, long time. And my experience with exams and essays sometimes was really unpleasant. And I'll explain what I mean. I would never miss a class. I would take extensive notes. I would ask questions. I would read the book, etc. Then, you know, I would get to the exam. And when I looked at the essays, I don't know how many times this happened, a lot. I'd look at the essays and I would think, where the heck did these essays come from? I don't have a clue. I don't remember any of this material being presented in class. I don't remember it in the book. I was dumbfounded by what the essays were. And I just thought to myself, well, okay, I guess I'm going to try and, you know, baffle them with BS, as they used to say, and try and get some points. But that just always seems so counterproductive to me. You know, there's a lot of educational literature that suggests that if you're vague with your students about what they should know, then they don't learn things very well. They don't know what to put into their brains. They don't know, they just don't know what to focus on. And in the realm of biology, there's just way too much for us to know in biology, such a vast and broad field that part of my job is just to try to point out to you what are the most essential things that you should know. And in that spirit, I want to be as transparent as I can. And when it comes to these essays, I don't want somebody to look at my essays and go, I haven't got a clue where this material came from. It's totally me. So I'll tell you, one of the essays on the exam is going to be about the steps in the scientific method. It's going to ask you to list the 7 steps in the scientific method. Explain what, in your own words, what happens in each step. It's going to ask you to define vocabulary words and that kind of stuff. So if you're spending any time studying the PowerPoint and any documents that elucidate the steps in the scientific method, let me assure you that there will be an essay on the exam, one of the possible essays you could answer, that deals with the steps in the scientific method. Why? Because it's important stuff, right? It's important enough that it belongs in an essay on an exam that covers the material, okay? Anyway, how did I get off track here? Exams. Well, I'm happy to talk about exams. I will post what I perceive to be the essays tomorrow for the exam, okay? But as far as quiz 1 goes, that's where I was. Quiz 1, it is posted. I actually posted it yesterday. Believe it or not, I think there's a couple of people that have already turned it in. It's technically due by noon on Thursday. And here's the thing with this quiz. It's in 2 formats. It is in a D2L format. Okay, I'm going to go over here to, I'm on D2L now. Now, again, please understand that I'm doing my best. You know, when somebody's trying to work you through tech support, on the phone or even in a Zoom meeting, I'm not necessarily. But look, right here, under assessments, here's the current quiz, quiz 1. And of course, well, let me switch over to my student mode, okay? So I'm going to view this as if I was a student. Okay, I'm going to go to assessments. I'm going to go to quizzes. There's quiz 1. And here are the questions. Now, I don't know why this is cut off like this, because I think when you actually look at it, it's not cut off. Does everybody see it? I don't know why it's cut off that way. I have no idea. I played around with that yesterday a lot, and I could not figure out why it was doing that, okay? But, so here it is on D2L. This is the very first time I've ever posted a quiz on D2L, okay? So, I am assuming you can go to it on D2L, and you can find it that way. But please help me here. If you have trouble with that quiz, please let me know. Because the other alternative, for what it's worth, is you can go up here to my courses. All right, and it's, you know, loading. Go down here to where it lists the credit course, just like it shows up on mine, right? Go to Drive. Go to Bio 156 Summer Session B. That's the only folder that's in there. And then go down here, and sure enough, where is it? It's right up here. Quiz 3, there's a Word document which you could download, you could fill in, and you could email me as an attachment, right? Or you could take you could fill it all in and take a picture of it with your camera and then send it to me that way. All right? So at least in the beginning, I mean, if for some reason every anybody has no problem whatsoever with the D2L quiz that I posted, if it just flies nicely, that would be a miracle. If it flies nicely, then I may start putting all my quizzes there and not have an alternate document posted in my PIMA. But you know, sometimes I have trouble opening things in my PIMA, but I can open them in D2L. Sometimes I have trouble opening them in D2L, and I can open them in my PIMA. I'm admitting it. I've used my PIMA for years. I'm relatively comfortable with my PIMA. But the bottom line is that I'm going to try it in both formats for now. All right, just until it seems as if I know what I'm doing, right? And that's what it comes down. This is the very first quiz I've ever imported into D2L. It looks good, but I don't know what it actually, how it actually is going to work in terms of you turning it in. And again, there was a time when I could have just asked somebody in the office next to me to come and look over my shoulder and help me with it, but not today. Because none of my cats, my dog, anybody around me knows how to use D2L better than me, which is sad. So, all right. Okay. Oh, I also mentioned on here that I'm going to post another quiz on Thursday, and it's going to be due on Saturday by noon. Now, you know, it's an assignment. Nobody's forcing you to work on it at 10 o'clock in the morning on Saturday. You could find some time to work on it before then. But I want to give you the same kind of time frame, 48 hours to work on it and submit it. You know what? I'm assuming people are going to do pretty well on these quizzes because they're not crazy, they're not crazy quizzes. A lot of thought questions on them and some other material. But you know what I forgot to do on quiz number 1? I apologize for this. I didn't put any metric conversions on it. No metric conversions. Well, let me tell you for a fact, quiz number 2 is going to have metric conversions on it. I don't know what I was thinking. There was plenty of material, and I started writing that quiz, and when it was all done, I posted it, and then I thought in the middle of the night, no metric conversions. What are we talking about? Well, believe me, there'll be metric conversions on the quiz number 2 that I post on Thursday. Okay. So I know there's people who are going to be mad at me and go, I worked on those metric conversions, Steve, and now you didn't give me any chance to demonstrate how well I know how to do the metric conversions. Well, quiz number 2, there'll be metric conversions on it for sure. All right. So before I leave this wee document, would anybody have any questions or concerns about it? The thought questions are valuable. It's worth checking the thought questions out and seeing what questions you can answer after every thing that we accomplish in class. Okay. Okay, I'm going to go here. I'm going to go back here for a little while. We'll take a break as always at about 2:30. But let's take a look at this slideshow, and I guess I'll start at the beginning though. We left off yesterday on slide number 9, if my notes are correct. But this PowerPoint is posted so you can study it. You can watch it 100 times if you want to. And I'm going to try and make some significant progress through it today. All right. So, what is science? We did all this already. Where does it work best? The hypothetico-deductive scientific method. Oh, this big picture that we did, I might come back to it later, but this big picture is where, I put this right up front so that people could kind of see how these portions of the 7 steps in the scientific method are linked together. Research question, explore research question, generate hypotheses, generate predictions, test predictions, analyze your experiments that tested your predictions, peer communication. But of course, I mentioned yesterday, and I'm sure you remember, that peer communication has a formal part and an informal part, and the informal part happens all the time. That's why I mentioned step 7 in step 1. The formal types of peer communication means you present your work at a scientific meeting or conference, you publish a paper, the kind of journals, and I'm going to mention this in the next slide, the kind of journals that publish peer-reviewed scientific papers are usually kind of famous journals like the Journal of the American Medical Association or the New England Journal of Medicine. Oh, there's thousands of peer-reviewed scientific journals. Again, the formal kind of peer communication tends to happen towards the end of your scientific study, but the informal happens constantly. That's where you're asking for help and advice, and that is used in every step. Okay? So, we were talking about making a research question better. And I think this would be an ideal time to look at this Alka-Seltzer lab just for a minute, okay? Because at the end of class yesterday, I sent people, well, I ended my talking, and I said, look, I want you to go and I want you to look at this lab. And I wanted you to just think about questions 1, 2, and 3. I'm sure everybody remembers that. And because all I wanted to think about was this question: will Alka-Seltzer dissolve more quickly in warm or cold water? And so, here we have a research question. I have to tell you that this research question is absolutely a rough draft. And what I mean is that this research question is not, I don't think it's very clear and precise. I really don't. I don't think it's very clear and precise. So we're having a class discussion now. This is a class discussion. My question is, would somebody brave enough, activate their microphone and just tell me, is there any word or phrase or anything in this question that is not perfectly clear to you when you looked at it?
So I was kind of wondering, like how much, how much Alka-Seltzer? Also, like specifically, what counts as warm? What counts as cold? And then what? I don't know what. How? How is how are you going to compare how quickly they dissolve?
Right. So let's just address. I'm writing down this stuff. I'm not going to save this document. So you're out there, you're going to take notes. So you said how much Alka-Seltzer, cold versus warm. And what was the last one that you said? How will we determine if it's dissolved more quickly? Is that what you were saying? Or okay, so really, I'm going to put that down there. What does more mean? Okay, great. Thank you. Anyone else have anything else when they looked at this question that just didn't seem as crystal clear as it could be? Certainly, these are some questions that the questions that were just proposed, or that the concerns that were just proposed, are certainly ones that would bother me. True, exactly.
One item we might look at is it like brand name Alka-Seltzer? What type of Alka-Seltzer? Is there a difference in manufacturer qualities, that kind of thing, that may affect its dissolve rate?
Very nice. My problem is I'm having trouble hearing people, and that's my own, that may be the volume that I have set here. So where am I? I managed to lose everything. didn't I? Where was all that stuff? I see. Here it is. So put it what type Alka-Seltzer, and what you were saying is what I think is Alka-Seltzer, and meaning, is it going to be brand name or is it going to be generic? You know, when I went out to buy Alka-Seltzer for this lab, I bought good old brand name Alka-Seltzer, and I had the option of buying generic Alka-Seltzer, and it was cheaper, as you might expect. But you know, the bottom line is that this is an issue that needs to be considered. What I asked people to buy was brand name Alka-Seltzer, and hopefully that's what most people bought. You know, the kind of brand name Alka-Seltzer that, you know, it's called Alka-Seltzer. If you buy it and it's not brand name, it has to be called something like effervescent pain relief or something like that. They have to. I mean, look at this. This Alka-Seltzer is kind of amazing stuff. If you read the box, it says fast relief of heartburn, upset stomach, acid indigestion, headache, body aches. I mean, gosh, this stuff seems like it cures just about everything. When I was a kid, I'm not joking, my mom had like 5 different kinds of Alka-Seltzer in the medicine cabinet. It was like high-tech medicine then. I mean, if I said to my mom I had a headache, she'd go, oh, let's go and get the right kind of Alka-Seltzer, and we'll drink that right kind of Alka-Seltzer. So anyway, this is an issue. Are we using brand name Alka-Seltzer or generic Alka-Seltzer? Definitely something that's worth considering. Anybody else have anything else that they look at this question and they go, well, I don't guess I totally understand what this word means or that word means? Because there is one word on here that kind of jumps off the page at me, and it may just be because have had some experience with Alka-Seltzer.
I have a question for you.
Yes, go ahead.
Would water hardness or salinity of the water make a difference? If you live in a hard water versus soft water place, would that make an issue? Or are you using tap water versus distilled water?
Right. So
then you don't get the bubbles to act right if you don't have a certain mineral content in the water. That may affect dissolving.
And I agree, absolutely agree with you. I think, I don't know this for a fact, but it doesn't seem to me that it would be okay to use distilled water in one cup and tap water in another cup, right? That tap water, especially in Tucson, Arizona, has a lot of mineral content to it, a real lot. You should look at my evaporative cooler. You don't believe that there's a ton of minerals dissolved in Tucson water. You just look at the outside of my evaporative cooler, and it is covered with minerals that have formed crystals as evaporated out of our normal tap water. So our tap water has lots of minerals in it. And so the kind of what I'm hearing is the question of, would it be okay to use different kinds of water, use tap water that's warm, but use distilled water that's cold? And this is certainly an issue that's worth raising. I mean, what we're doing right now is we're just discussing the research question. We're really sort of doing step 1, where we try to make the research question more clear and precise. But we're also sort of doing step 2, where we're just trying to understand the research question well enough that we can proceed forward in our scientific process. That's what we're doing. We're doing exactly what we should do. So thank you for mentioning the idea that type of water might be an issue. Any other, but let's just focus on this research question again. Will Alka-Seltzer dissolve more quickly in warm or cold water? No other words that jump off the page at anybody? Because here's, oh, sorry. Maybe somebody's
Quickly
chatting. Maybe somebody's chatting and I missed the chat. I hate that. Here we go. Yeah, thank you. Thank you, Alva. Well, more quickly is definitely an issue, right? Like, what do we mean by more quickly? But I agree that that one of the big, what I think is a big deal. Whoops. Okay, somewhere here we've got plenty documents up here. Here it is. Another. I don't want to open it again. Ugh. Okay, get there. Allowed Alka-Seltzer is the one I'm filling in. So I want to mention this because I think this is critical. What does the word dissolve mean? Thank you. I mean, managed to lose it again. It's here. Okay, so I have to tell you, I don't know how much experience people have with Alka-Seltzer, but I actually have a significant amount of experience with it because, as I said, I'm not joking. When I was a kid, my mom thought Alka-Seltzer was high-tech medicine. So how much Alka-Seltzer? Cold, what are you talking about? I mean, is this question, how much Alka-Seltzer do we need to test this, to do an experiment to try and get some kind of answer to this question? How much do we need? What do we mean by dissolve? What do we mean by more quickly? What do we mean by warm or cold water? And what about things like the type of water or the type of Alka-Seltzer? These are all great ideas that people have proposed, and this is exactly the kind of thing that you have to do when you're trying to analyze a question like this. Now, this isn't a very complex question, but it is a rough draft of a question, really, because I don't think you can actually answer this question with any clarity or precision if you don't know what you mean by dissolve, you don't understand what you mean by more or more quickly in this case, and I think knowing what we mean by warm and cold water is a potential issue because, again, here's the thing. Have you ever jumped in a pool and said, "Oh my gosh, this pool is so cold," and another person jumps in and goes, "Oh, this pool is perfect. This is exactly the right temperature," and someone else jumps in and goes, "Oh, this pool's too warm. I feel like I'm taking a bath." Warm and cold are very sort of subjective terms, but all of these things are some of the stuff we have to consider when we are thinking about actually conducting a scientific experiment in order to answer this question. So I'll tell you that I think how much Alka-Seltzer is going to be pretty simple for us to define, right? Because I actually said all you need to do this lab is 2 tabs, maybe 3 if you want to replicate something that I'm going to do right in front of you on camera, okay? So I think the amount of Alka-Seltzer that we're going to use is going to be sort of about the minimum that we can use. I'm not convinced we would learn much more if we dissolved 27 Alka-Seltzer tablets than if we dissolved 2. So based on the equipment that I've asked people to get, the equipment list. Here it is. I said, Alka-Seltzer tablet, you will need 3 tablets. They usually come at 2 in each foil packet. So, and I mean, maybe some people have already gotten this material. I hope so. If not, we're not actually at the point where we need the Alka-Seltzer today, but please get it as soon as you can. And I again wish there were places you could go where you could just buy a few Alka-Seltzer tablets. Hey, did anybody try to go to, what was it, Whole Foods and buy Alka-Seltzer? Because I remember somebody the other day said that they thought you could buy one packet of Alka-Seltzer at Whole Foods. I think it was Whole Foods, right? And I haven't tried to go do that, but I mean, that would be wonderful if you could do it. I've noticed in some Circle K's, they will sell like a single little thing with 2 Alka-Seltzer tablets in it. And, but anyway, this is a pretty safe experiment, a pretty easy experiment to do. So I'm hoping you're able to locate Alka-Seltzer. Now, so how much Alka-Seltzer? 2 tabs probably is what is going to be the perfect amount, maybe 3. Now, as far as cold versus warm goes, let's just say we would really like to create for this experiment something that's distinctively warm and something that's distinctively cold. And since we don't necessarily have thermometers to work with, does anybody have any suggestions about how, as a group, because we're all going to do this experiment ourselves, right? Everybody's going to do this experiment. As a group, how could we define cold and warm in a way that sort of, I don't know, tries to create similar conditions for all of us? Anybody got any ideas?
Use glass of ice water for cold and the water on the hot setting out of your tap for warm.
Yeah, that sounds great to me. What if we decided that cold means, let's say we decide that cold is going to be water that's been in your refrigerator for an hour. Everybody sort of think that would, I mean, if you put a certain amount of water, not a lot, you know, you're going to use a little clear glass, let's say. You put a certain amount of water in a little clear glass and you sat it in your refrigerator for 1 hour. You think it would be cold at the end of that time?
How much water?
Well, we'll get to, yeah, you're right. I mean, if you put a gallon, if you put a liter of water in your refrigerator for an hour, it wouldn't maybe get as cold as if you put, say, 200 milliliters, right? So how much water is an issue? And we should talk about, you know, some water quantities. But what if we defined cold? Okay, so cold equals.
But usually, when you take Alka-Seltzer, they normally actually take it with a cup of water. So a cup of water is about 8 ounces. I know I'm not using the milliliter thing, but
Right.
it should be about the recommended dosage, so you get the right amount of activity.
Right. Well, so let's keep that in mind, and we'll think about volumes in a minute. Right now, we're thinking kind of about how are we going to create cold water. So water refrigerated for, well, I mean, I said 1 hour, but maybe we should refrigerate it for 2 hours or 3 hours, or maybe we should refrigerate it for a half hour. What do people think? I mean, let's think that we're going to use half a cup of water. Okay, now I don't like to use the word cups, but here's the thing. There's about, what did I do? I actually need to go get my cup measurer, but there's about 30 mils in an ounce. Okay, nobody needs to worry about knowing that, but there's about 30 mils to an ounce. So a half a cup would be about 120 mils, right? It'd be 4 ounces. Half a cup would be A cup would be 240, half a cup would be 120. So let's just say that we used roughly half a cup of water, which would be about 120 milliliters of water, and we refrigerated that for an hour. I feel like it would probably be pretty cold by then, wouldn't you? So let's just do it. Cold is water refrigerated for 1 hour. What is the temperature in most refrigerators? Anybody know? I mean, there's a setting that you want to have in your refrigerator, most to keep food warm. I think to keep food refrigerated, most general refrigerators, they try to keep food at about 40 degrees Fahrenheit. So 40 degrees Fahrenheit. In order to get to convert that to centigrade, I have to subtract 32. So 40 minus 32 equals, whoops, be good if I had it on. 40, I don't really need a calculator to subtract 32 from 40, but 32 equals 8 divided by 1.8 equals, no, that can't be right. Hold on a second. Calculators. Yeah, I guess that's actually right, isn't it? I took 40 degrees Fahrenheit, I subtracted 32, and then I divided it by 1.8 equals 4.44. So 40 degrees Fahrenheit is about 4.5 degrees centigrade. But we don't have centigrade thermometers. That's why we have to make these decisions. We really don't have the basic equipment we would have in a classroom. So let's define cold water as water refrigerated for an hour. And let's define warm as could we define it as what we're going to call hot tap water, meaning I don't want anybody boiling water or microwaving water. All I think we could do for warm is we could simply run the tap until you say that's hot water, and then we use that water, right? This isn't, this doesn't sound totally scientific, but that's because we don't have access to thermometers. But I feel like we do need to have some kind of standard definition for cold and warm. And I have to tell you, in the classroom, when I do this lab, I use hot running water from the sink for warm water. And that hot running water from the sink, it's about the temperature of a really hot shower, right? Where you touch it and you go, that's hot, that's hot enough. I wouldn't want it any hotter than that. Nobody's going to get burned by it. But let's use this as our definition for cold and warm. So at least we know that when everybody does this experiment and we report all this data, because I'm going to have everybody report their data back, we kind of have a somewhat basic idea of what people mean when they say cold and what they mean by warm. True? It's not perfect, but it is better than just leaving it completely up to just completely, completely subjective. We at least have some kind of definition. Now, what about the type of water? Well, here's the thing. I think we don't want any special water. You're going to use your tap water in your house. Okay? Now, here's the great thing. someone mentioned before, and I apologize, I don't know everybody's name, and I didn't know when it was coming up, but here's the thing. It would not be okay to use distilled water that's warm and to use tap water that's cold. It wouldn't be okay to use distilled water for cold and tap water for warm, because lost it. It wouldn't be okay to use different kinds of water. We're going to use the same water in both conditions. And that's going to be good old tap water, right? That's easy to get, assuming everybody, no matter where they are, they have tap water. Now, again, somebody mentioned this earlier, that they said, well, what kind of water? And what kind of water is an issue, because you can't use two different kinds of water, one in warm and one in cold. By deciding that we're going to use the same kind of water, tap water in both cases, we've eliminated that as a variable. We've eliminated that as a variable. We're going to use the same kind of water in both cases, tap water. Okay? Look, I need to get up and stretch my legs. When I get up, I'm going to go get some equipment, because I'd like to explore what it means to dissolve Alka-Seltzer. Okay, so we're going to take an official 10-minute break now, which is right about on time, about 2:30, 2:31. So we're going to be back here in 2:41, and I'm going to get some equipment that we can use for a demo. Okay, all right, everybody, 10-minute break. I put the smooth jazz on. Stretch, move around, etc. All right, everybody back?
Still here.
Hello. Very nice. So look,
Yep.
let's go ahead. Question? Or just letting me know you were here? I've got this fear is I'm going to come back and I'm going to start talking and, nobody will be here. So, look, let's do this for a second. I want to just go back here real quickly. We've made some decisions sort of here about what we mean by cold and warm. Nobody would have any trouble setting these conditions up in their home. I'm sure you can. I'm sure get tap water. You can refrigerate water for an hour. You can get hot tap water out of your hot water. I hope that's true. So let's look at this question here about dissolve, because that is an issue. Can I just take this away for a minute, and I'm going to show you good old Alka-Seltzer. Now, I'm opening up this packet, and I'm happy to say that inside this packet there's absolutely brand name Alka-Seltzer. Boy, yeah, I guess it's there. I can actually read. It says Alka-Seltzer. Of course, it's backwards, but that's the mirror image effect. This Alka-Seltzer tablet has Alka-Seltzer embossed on it, and the outer edge is kind of, flared up a little bit. This is the high quality Alka-Seltzer stuff. It's funny, generic Alka-Seltzer, it looks a lot like normal Alka-Seltzer, except it has no edge on it, and it has just like some numbers and letters on it. I think it says something like L421, the Alka-Seltzer tablet that is generic. And, it looked just like an Alka-Seltzer, but it doesn't say Alka-Seltzer, and it just says L421 on it, or something like that. Sometimes in class we would use generic Alka-Seltzer because that's all we had. But every time I see that generic Alka-Seltzer, I imagine this number L421 on it, and I have this picture in my head of somebody, mom or dad, and they're putting away socks in their teenager sock drawer. And in the bottom of the sock drawer, they find this round tablet like this. It says L421 on it. And they think, oh my gosh, what is this drug that's in my teenager's sock drawer hidden down in the corner of the drawer? So they go to their computer or they go to their phone, they call poison control, and they go, oh my gosh, I found some kind of drug hidden away in one of the drawers of my teenager's room. I need to know what my teenager's taking. So they ask questions. Well, what is it? It's round. And how big is it? About the size of a quarter. And what does it say on it? It says L421. Of course, if it said Alka-Seltzer, it would be no problem. L421. So the person at Poison Control or whatever kind of starts clicking it in their computer. Of course, you can do this yourself at home these days. You just go to like pill identification on Google, and you'll go to these sites where you plug in information. So anyway, the mom or dad of the teenager is sitting there expectantly waiting, and finally the Poison Control people come back in line and go, excuse me, are you sitting down? Yes, okay, I am. Well, that pill you found in the sock drawer of your teenager, it is generic Alka-Seltzer. And I imagine the mom or dad going, oh my God, I did not know you could get high on Alka-Seltzer. But the truth is, you can't get high on Alka-Seltzer. If you were to just eat a piece of this tablet whole, then you would not enjoy it at all in any way. But what we're thinking about is this word dissolve. Now, take a look. I've got my Alka-Seltzer tablet right here. And then look what I found in my cabinet. 2 pretty much identical glasses. I mean, this is as close to identical as I'm going to get. You can see these have, like, I don't know, this one has a bunch of presents all over it, but that shouldn't affect anything. And this one has Christmas ornaments. These somehow are some little paired holiday glasses. But what's important is they're the same size glass, the same kind of glass. Like I said, I need you to find 2 identical glasses. So I've got the 2 identical glasses here. I'm ready to go. Now, I also went into my kitchen cabinet, and sure enough, there it is. Here's a Pyrex cup measurer. One side is the evil imperial units, like cups and ounces and those kinds of things, pints and cups and things that are part of the English or imperial system that I wish we could forget it even existed. But then, next to it, the other side of it, excuse me, is, I don't know if we'll be able to see this or not very well, but thinking if I shove a piece of paper in it, it might make it a little easier to read. On the other side, yeah, on the other side, look, I know it's backwards, but it has milliliters, right? So this cup, well, like I said before, 250 milliliters is just right about a cup, about 30 mils per cup. But that's not a correspondence that you really need to know about. But I can measure 100 milliliters, 150 milliliters, 200 milliliters, 250, 300, 350, 400, 400. So it'll hold about 500 milliliters. So if 2 cups is close to 500 milliliters, then as I said, it's about 30 mils per ounce. So 240-ish mils per cup. But what's important about this is that I could use this cup to measure out some exact amount of water to put in here. Now, I have to tell you, part of my decision is going to have to do with this cup and how much water I can put in it, because I don't want the cup to be too full. I don't want it to be too empty either. So I'm not using some tap water here. I'm using some bottled water, but I'm just going to fill the cup up to some, I have no idea how much water this is, really. No idea, really. But I filled the cup up a little less than 2/3 of the way, right? So I am kind of curious. It's almost exactly 100 mils. But, you know, right now that doesn't make much, really doesn't make much difference. Not under these conditions where I am just doing a little demo, okay? I don't care what the water temperature is now. I don't know. It's not warm, it's not cold, it's room temperature probably, right? I don't really even care how much water I have in, except I don't want to have so much water that it's close to the top where it might bubble over. And I don't want it to be so close to the bottom that there's hardly any water in it. So I'm making this decision about using this much water. Now I'm going to say it. Look, when you do this experiment, you're going to want to make sure you have the exact same amount of water. Somebody mentioned this before. How about the amount of water? Well, do you think it would be okay in one of these cups to have 150 mils, and in the other cup, let's say the 150 mils is warm water, but in the other cup, you only use 50 mils? And I'm sure when you hear that, you think, well, wait a minute, 150 mils of warm water, 50 mils of cold water, that just doesn't seem right to me. And you're right. Your intuition is right. There's something wrong about that. What's wrong is that the amount of water could affect how the Alka-Seltzer dissolves. It could. If you only had this much water, it could definitely prevent the Alka-Seltzer tablet from dissolving at all. All right, just to be clear, the research question didn't say will Alka-Seltzer dissolve faster in a lot of cold water compared to a little bit of warm water? No. It just said cold versus warm. We are going to need to control how much water we use so that we're using the same amount of water in both cases. That is a controlled variable that we have to eliminate by making sure we use the same amount of water. Okay, we'll come back to that. Here's what I want to do now. Now, is anybody out there, can anybody help me with this? Because what I would like is if somebody in the viewing audience would, in fact, time something for me. So if you have a stopwatch, or you have, a stopwatch on your phone, that would be wonderful. Will a couple people at least volunteer to do some timing here? I'll give you time to find your phone and set it up for stopwatch, or I don't know. When I'm in class, I wear a watch and it has a stopwatch on it. But are there a couple people who will do the timing for me? If so,
I could do it if you want to.
Thank you very much. I appreciate it. And Abril, you'll also do it?
Yeah, I can do it too.
Good. Did I pronounce your name correctly, Abril? Yeah, good. Thanks. I'm trying to pronounce it. All right, so good. I'm now going to ask you to time. Somebody else wants to do it, that's fine too. But here's what I'm going to do. I'm going to take this Alka-Seltzer and, I wish I could sit it on something that would make it a little bit more visible. Must be something here within my range that would make it a little bit more visible. Maybe this will work. Okay. No, almost. Okay, so it's something just a little bit taller than that. Maybe this will work. Still not tall enough, huh? Oh, wait. Nope, still not tall enough. I didn't pre-think this. Anybody notice this?
Hey, Steven.
Yes.
So I have two Alka-Seltzer in front of me, and I was just looking at the label in the back of it, like the active ingredients. Would the sodium bicarbonate be a difference between like two Alka-Seltzers if there's one that's original and if there's one that was extra strength?
It could be. It could be, definitely. And absolutely it could also be different if you're using generic Alka-Seltzer versus brand name Alka-Seltzer. The ingredients might not be exactly identical. Okay, let me stand up. I got to get something bigger to sit this on so we can sort of see it. I'll be right back. All right, I think I found it. And this, I knew this would come in useful sooner or later. Clorox disinfecting wipes. Yay! I only paid $300 for these on eBay. Okay, now, everybody can see the glass? Everybody ready to do timing?
Yes.
All right, I'll tell you when to start. 1, 2, 3, start. Okay, so the Alka-Seltzer has been dropped in the water and immediately it starts bubbling and fizzing. That's totally normal. That's what it's supposed to do. There's a chemical reaction in there that we could talk about, I suppose, if we were in chemistry class, but the bottom line is that there is a chemical reaction happening in there, I think, between the sodium bicarbonate and the citric acid. You need to think about this. Sodium bicarbonate is a weak base, and citric acid is a weak acid. Anyway, it's in there. Now it's floating kind of on the top, and stop the timer now. Okay. So, what kind of numbers did we get?
I got 47 in 11 seconds. I was actually 49. I like missed it by a second when.
Oh wow! So one of us got 46.91 and one got 46.88, 47.27. I mean, these are all pretty. I mean, I was hesitating, kind of like, okay, now, right? So that's what I said. So the bottom line is that people were waiting for me to say we've got all numbers that 46, 47. You know, these are all our numbers that are pretty close. They're pretty close. The numbers are pretty close to each other, which is great, but not identical, which means that at some level, there's some sort of human variability built into this, and that human variability is something we need to consider.
Yeah,
but
right.
Here's the thing. It's a little difficult for me to show this to you. I mean, I think I've admitted to you that I'm kind of a dinosaur, and in my regular classroom, I would have an overhead projector that I could sit this on. Oh, and that's true. Hey, thanks for mentioning it. Somebody said, could there be a delay on my end? There certainly could be, so that between the time I said stop, there could be a little bit of a delay. But here's what I'm sort of trying to show you, is that there is still a significant amount of like powder, not to mention bubbles in this. I do not want to spill any water on my computer. But the bottom line is that there's still, down here, if you can see it, there's still a little pile of powder there. And when I sort of stirred the water around, it emphasized that there's still a pile of powder. Now, why did I do this whole thing? Because I've got a lot of Alka-Seltzer, and hi, Kendall. Because I've got a lot of Alka-Seltzer. No, it's because the word dissolve is a question here, really. What does dissolve mean? Well, when I was a kid and my mom would give me Alka-Seltzer, she would put it in as little water as possible, because I got to tell you that drinking Alka-Seltzer can be really disgusting. And if you're not, you know, I mean, the flavor, it's bubbly, etc. So when we were kids, my mom would use a little glass, put in a little water, drop the Alka-Seltzer tablet in. And let me tell you, you would not want to swallow it when the tablet was still intact, because it could get stuck in your throat, and that would be really, really unpleasant. You wanted to drink it as soon as the tablet had fallen apart. Once the tablet had fallen apart, then you sucked it back. And even then, I thought, I'm going to hurl, right? It was pretty bad. So I'd be standing in front of my mom holding the glass like this, and she'd be looking in, and I'd be going, now? No, not yet. Now? No. Now? No. Now? Yes. And then I would slug it back. And it was all based on when the tablet was dissolved. Now, why? Well, now in that particular case, it was so I wouldn't be swallowing an intact tablet. Right? That would be bad. But in our case, just for the record, there is still powder in this. If you define dissolve as zero powder, no powder left whatsoever, no bubbles, no powder, then you know what? You'd still be running your stopwatch. You would still be running it, because there is still a little pile of powder down in there. Now, I could, I suppose, stir it up, and that might help it dissolve.
Yes, I'm going to ask you to stir it up again.
Excuse me?
I was going to ask if you would stir it again, would that increase the dilution of it?
So, you know, ask me the question again. I didn't quite catch it.
I wanted to know if you were to stir it up again and re-agitate it, would it help everything dissolve again even more?
Yes, absolutely. I mean, based on my experience with it, the more I agitate it, the more stuff will tend to dissolve, right? Like I just agitated it and the little pile of powder there got smaller, right? So there's no doubt about it. Stirring, I mean, do you think it would be okay to stir it in the warm water, but to not stir it in the cold water? No. Whether you stir it or not, it is a potential issue, right? But the bottom line is that we, if one of us, and all of us, the big group of us, if one of us decided to define dissolve when the tablet disappeared, there was still some sludge in there, but the tablet had disappeared. The tablet was disintegrated. If one of us defined dissolve that way, and another one of us decided to define dissolve as no powder left, no bubbles left, we would get dramatically different numbers. And under the right circumstances, that might be fine. But I think if we're going to do this experiment en masse this way, we kind of want to have the same definition of dissolve. And so I'd like to define dissolve as it's dissolved equals a tablet has disintegrated. You cannot see the round, nice tablet anymore. There could still be bubbles. There still could be some scum or sludge associated with it. But basically, we're going to define dissolve as the tablet has disintegrated. Now, I hate to ask this, but is everybody writing this down? The bottom line is that we want to check the chat real quickly, and it's mostly, it could be delay, it could be etc. Yeah, all these numbers. You know, I'm amazed at how different these numbers could be. You know, I mean, they're not huge variability. 46 point. There's only a difference of about half a second, which that's pretty good. I mean, if there's a delay, if that represents the delay, then that's certainly not that bad. Okay, so I have to mention that what we're doing right now is sort of part of step 1 in the scientific method, and it's also part of step 2. Okay. These overlap a little. Remember, step 1 was all about creating a carefully worded and precise research question. Well, define, describe, clarify, identify, set criteria, all that kind of stuff. Well, that's exactly what we're doing. Step 2 in the scientific method says this: review the literature, and you notice I put the word literature in quotes, to explore the research question. I'm going to come back to this, of course, okay? Sorry, I went way too far back. Here we go. So, step 2. Review the literature to explore the research question. Step back and study the research question. Is it really clear and precise? What do we already know about the topic of the research question? Now, historically, what we would do is we would consult what's called literature related to the research question. And historically, that literature should have included what is called primary literature. Primary literature is the published reports of original scientific research, peer-reviewed, which means that it never got into print until it was looked at by experts. Journals like the Journal of the American Medical Association, the New England Journal of Medicine, the American Journal of Nursing, these are all primary literature, okay, that you could consult as you do step 2 to review the literature. But there's also what's called secondary literature, which is almost anything else. Discover Magazine, Psychology Today, Scientific American, a biology textbook, the TV guide, interviews, videos, YouTube, Google, etc., etc. Secondary literature is virtually any other source of information these days. Now, you know, when I was your age, is when I had to do step number 2, I inevitably had to go to the library, and I would look at a lot of primary literature, if any existed on the topic, and then I would look at secondary literature, but there was much less available at that time, really. I mean, there weren't very many. There was Scientific American was around for sure, but I mean, you'd have to go in the library and sit and look at stuff that way. I know this is going to be shocking to you, but there was no Google then. Google didn't exist when I was in graduate school doing these things. Computers barely existed. So I wanted to mention that what we're doing right now is we're actually sort of doing step 1 and step 2, where we are trying to make the research question better, clearer, but we are also sort of doing step 2 where we're trying to understand the research question. And so we didn't really know what dissolved meant. So we looked at the tablet dissolving, and I guess I made this decision that we were going to define dissolve as when the tablet has disintegrated, because I got to tell you, there's still some scum and sludge here. If you defined dissolve as 0 scum and 0 sludge, well, you're still timing, and it's what, 10 minutes later. So it'd be better for us to when we're going to collect this data, it would be better if we had a standard definition for dissolve. Okay? Bottom line is, all of this is going to be. So, well, here's the thing. There's still bubbles in here, Edward. There's still bubbles, so we'd still be timing. And honestly, I don't think we want to time until there's 0 bubbles or 0 scum left, because I'm going to be honest with you and tell you that just sitting here like this could still have a bubble or 2 in an hour, and that's just way too long. Okay, so when we look at it, you're going to study it, you're going to look at it. That's why I actually said if you had 3 tabs, might be better, because you could just throw 1 tab in water and watch it and go, oh, I see what Steve means. There comes a point in time where the tablet's gone, and it would be safe and good to drink it then. I'm not encouraging you to drink it, but it would be safe and good to drink it then. But there's still some scum and some sludge in there, but I'm going to ignore that. Okay? Bottom line is that thanks to your help, we were able to look at this question and make it better. We now know that we're probably going to use 1 Alka-Seltzer tab in cold, 1 in warm. Here's how we're defining cold and warm. We're going to use, well, I don't know what people have. I was sort of hoping most people would get brand name Alka-Seltzer, since that's what I said. So let's just assume it's mostly going to be brand name. The type of water that we're going to use, easy. I don't want you to go and buy any fancy Fiji water to do this in. That's a future experiment. Will Alka-Seltzer dissolve more quickly in warm Fiji water or cold Fiji water? But no, we don't need to do that, right? We're going to just use good old tap water. All right, now, the definition of dissolve is going to be the tablet as disintegrated. We can't see the tablet anymore. All right. Everybody writing this down, I hope. Right. Because I'm not sure. I mean, this document is my original document. Maybe I will save it anyway, just to keep these notes up here. I'm going to save it. Okay. Now, what other word in here is bothersome? And here's the other word, this word more. What does more mean? Look, here's the thing. A word like more is always a problem. It is always a huge problem. Because what more means is that you have to decide, you're going to end up with two numbers, one for cold, one for warm, right? Way down here at the bottom, I put a little data chart that you could fill in. And so just for fun, I'm going to say, okay, cold, which we don't have to actually measure, and warm, which we have a definition for these. In cold, it dissolved in some number, 67 seconds. Temperature is, by definition, times the dissolve. We'll use seconds. That's a metric unit, believe it or not. Seconds is a metric unit. So 67 seconds in cold. What if it dissolved in 73 seconds in warm? Is that a big enough difference that we feel comfortable declaring that there really is a big difference? I mean, look, if it was 67 and in warm it was 730, I'm pretty sure that a statistical test would tell us that these two were different numbers. But the difference between 67 and 73, to me, this is only 6 seconds. 1001, 1002, 1003, 1004, 1005, 1006. And I would be hesitant to say with great confidence that we have determined that it dissolves faster in warm than cold if the only difference was a few seconds like this, right? Just a few seconds. I think that, and we'll talk about hypotheses in a few minutes, but I think that we need to decide what more means. And in this particular case, well, is what would be great. If you could do a statistical test, you could do a statistical test. I'm not asking you to do it, so don't stress out. Right? But if you could do a statistical test, like a chi-squared test or a t-test, well then you could go, oh, there's no statistical difference. Yes, there's a statistical difference, but that's not really, we're not going to do that, okay? The reason is that you individually, for this one experiment, there's no statistical test that's really going to give you a good answer. There's none, as far as I know. I'm not an expert at statistics, but one little experiment, 2 Alka-Seltzers dropped in water, you compare the numbers, unless the numbers are really, really dramatically different, which they may be, then there's no statistical test that's really going to help us with that. So what we have to do is basically set standard criteria, whatever that is. And so the question is, what does that mean? It means that we want a number, some number that's definitely greater than 0, but probably not 300 seconds, some number between 0 and 300 that if there was a difference of at least that amount, then we would feel totally comfortable declaring that there really is a difference. I mean, again, if one dissolved in 67 seconds and one dissolved in 68 seconds, nobody would think there was really a difference, right? too close, because just a little bit of hesitancy could make that difference. So there's got to be some kind of cutoff that we use to determine what we mean by more. Again, in many experiments, we would use a statistical test. We would set it up to do that. And then we would end up going, there's no statistically significant difference, or there is a statistically significant difference. But we need to set a standard criteria. So what do people think? What should we set? How are we going to determine a winner? I mean, is 1 second, if there's 1 second difference, is that enough for us to really declare that it dissolved faster? There's 100 seconds. Is what?
Oh, I just said, what about like 10 seconds?
Yeah, I mean, 10 seconds seems fine to me. I mean, 10 seconds, I mean, if it dissolved in 67 seconds in one and 77 seconds in the other, I feel like 10 seconds is a big enough difference that we could feel comfortable with it. Now, here's the thing. If you set that number too small, then it might just fall, that the results might just fall inside the just natural variability, the little bit of human error that could occur might fall within that, and we would be uncomfortable with declaring a winner. If we set it for 5 minutes difference, there has to be at least a 5-minute difference, well, then we probably would never be able to declare, that there's any difference whatsoever. So, I mean, 10 seconds seems like a great number to me. Let's use
quick can't talk. Quick clarification.
Sure.
By disintegrated, do you just mean like it's no longer round, like it's not a full tablet anymore?
It's gone.
Okay.
Right.
There's still like the sludge at the bottom, but the tablet itself is
right. Okay. So the tablet is nice and round. By you observing it, you'll be able to see that there will come a point where I did it, right? I did it. I'm like, now, okay, because I was watching the tablet, the last little fragments of what looked like the tablet to me were disappearing, right? So that's what I mean. I basically mean in this case that that the tablet is gone. Oh, is there still bubbles? Oh, sure. Is there still some leftover tiny fragments of tablet? Yes, but do I see anything that looks like the round tablet, or even a portion of the round tablet, the intact round tablet yet? No, then it's gone. Okay? And I got to tell you that when you do science like this, and this is what we're really doing now, we're doing some good science, is somebody could go, Steve, if I did that experiment, here's what I would do. I would drop the tablet in, I would immediately start stirring with a spoon, and I would time it until there was no scum, no sludge, no bubbles left. And I would say, fine. I mean, under certain conditions, in any experiment like this, there's always more than one way to do it. There's always more than one acceptable way to do it. But the bottom line is that what I'd like to be able to do at the end, and I'm hoping this will happen, is I'd like to be able to collect everybody's data and then put it all together and do a statistical test on it. And I can do that with 20 people's data, right, including my own. With 20 people's data, we could do a statistical test and decide, okay, there is a statistically significant difference. But if one person defines dissolve as the tablet's disintegrated and another person defines dissolve as 0 bubbles, 0 sludge, then those two numbers are going to be so different, they're going to affect the general outcome, the picture, the decision-making process. So by setting some things as procedural standard, we're going to generate a set of data. Everybody will generate some of that data. We're going to generate a set of data that is useful for us to look at and consider, okay? And I have a graph. I can throw that information in a graph and show you the graph and talk about the graph and all that kind of stuff. So does anybody object to us setting the standard criteria as 10 seconds? There must be. So that's what that means is I'm going to put this in. I'm going to put this right here, okay? That's what this means. There must be at least a 10-second difference in the time to dissolve, or we will declare that there is really no difference. Okay? Does everybody see what I wrote there? There must be at least a 10-second difference in the time to dissolve. Would declare there's really no difference. Because who knows? They might dissolve the exact same rate. We don't know that. Oh, you might have an idea about what's probably going to happen. You know, remember I mentioned in step number 2 that one of the things we could do is Google. Well, you know what? If you Google this research question, will Alka-Seltzer dissolve more quickly in warm or cold water? Do you know you're going to get about 10,000 hits? Because this is a very standard experiment. And if you read through the first 2 of those, and you agree with their experimental design, you're going to go, you know what? I don't even need to do this experiment. I know exactly what's going to happen. But I don't want to do that. I mean, in the future, when if we do more science like this, we might Google it and see what Google has to say about it. But this is a pretty famous experiment designed to teach about science, and so there's plenty. I mean, you'll find Mrs. Smith's 6th grade science class in Oshkosh, Wisconsin, that published on their class website the results of this experiment, right? Or something like that. But I just assume we didn't do that, so it really wouldn't make much difference. I mean, it's not going to affect the outcome of our experiment. Okay, so so the bottom line is that we've done some important stuff here. Okay, I'm going to put a 1 here where we decided we're going to use 2 Alka-Seltzer tablets. I'm going to put a 2 here where we defined cold and warm. I'm going to put a 3 here where we defined what we mean by more. I'm going to put 4 here where we decided that we're going to use brand name Alka-Seltzer to the best of our ability. Okay. I mean, there's part of me that just hates having to send you out to get some darn Alka-Seltzer under these conditions. But the type of water is going to be tap water, and the word dissolved, what does it mean? We've defined the word dissolved as the tablet has disintegrated. So, you know, the bottom line is that I probably should have put this information down here. I was hoping up here, and people did tell me this. They would go, well, I don't understand what we mean by Alka-Seltzer. I don't understand what we mean by dissolve. I don't understand what we mean by more quickly. I don't really understand what we mean by warm or cold water. And people told me that. Now, down here in the second part, I'm going to be lazy here. In the second part here, you know what, before I copy this, it's going to spread it out a little bit so it's not a little, whoops, a little bit easier to see these things. Okay. I'm actually going to put the same information down here too. Right. From the top, we've identified words like cold and warm, more, dissolved, all that kind of stuff. And in the second question, in question number 1, we identified those things. And in question number 2, we clarified them, right? Isn't that what we've done? We've basically clarified everything to the best of our ability. And I appreciate your help in doing that. That is what you have to do science well. Now, let's just look at step number 3. Okay, step number 3. Because remember yesterday what I said was, you know, do step number 1, which I'm sure you did, and I'll get a chance to see that when you turn this assignment in. Do step number 2, and I'll get to see what you wrote. I mean, look, we've worked through this as a group, like a lab group, so you certainly can feel free to use what I have up there, right? Then it said, look at the equipment list above and think about the research question and design a very basic experiment to test this research question using the equipment on the list. Explain your very basic experiment below. So, I'm curious about what people put here, but I'll bet that most people said this. I'm going to get 2 identical. Oh, go ahead. Can you get a copy of the notes? You mean the notes that we're looking at right now, Kendall? Yeah, I can try. I mean, the bottom line is I could send, when we're done with this, if you email me, I could send it. I could send this as an email attachment to you. Right, but in some respects, I'm also sort of thinking it might be good to just, you know, I mean, while you're sitting there listening to me go on and on, you can just write some of this stuff down and incorporate it into your document later. But anyway, so here's what I'm guessing most people are going to write. They're going to say, all right, I'm going to get 2 Alka-Seltzer tablets. I'm going to get 2 identical containers. I'm going to get 2 identical amounts of water. One kind of water, I'm going to call it cold, and one kind of water, I'm going to call it warm. Then I'm going to get some kind of timer. I'm going to drop an Alka-Seltzer tablet in my warm water, and I'm going to time it. I'm going to put an Alka-Seltzer in my cold water, and I'm going to time it. And then I'm going to look at the 2 times, the time to dissolve. I'm going to look at those, and I am going to think about what that means, what the answer to the question is. I mean, I'm guessing most people would design a little experiment like that, and honestly, that's just plain fine. But you can already tell that this question is more complex than you might have thought at first glance. So I'm expecting in step number 3 here for people to design a very basic, simple experiment, kind of like what I just described. Okay, and it's fine. I mean, don't worry in step number 3 about all the little details we've just added, because technically, I'll come back to your question. Technically, we've gotten kind of technical here, and we've tried to, you know, think about every word and analyze it and everything. So The question that just came up, which I want to address, is this question: did we decide how much water to use? And the answer is no. And in fact, the answer, we might want to keep this as something that we're going to control. I'll explain what that means. Okay, here's the thing. In your own experiment, you're going to need to use the same amount of water in both cases. It would not be valid. No, valid's not the word I'm looking for. It would not be appropriate to use 100 mils of water for cold and 200 mils of water for warm. We want the amount of water that you use to be the same, but again, remember this issue. You might find that you've got little glasses like this size, which, remember what I did? I poured a random amount of water in here, tried to fill it about, 2/3 up. I didn't want to get too much water so it bubbles over. And I then poured it out and discovered it was about 100 mils. All right. But the bottom line is you might have a smaller container. A shot glass wouldn't be big enough, right? Or you might have a larger container. And so you're going to have to decide in your experiment what is an appropriate amount of water to use. And it's sort of based on how big your clear containers are. They could be clear plastic containers. They could be 2 plastic cups the same size. They could be 2 glass things like this of the same size. I mean, they could be, maybe you have 2 identical Pyrex milliliter measuring cups like this, and you're going to use those. But then you have to decide what's the appropriate amount of water for the container you're using. Okay, so that's the answer to that question about the amount of water. You're going to have to decide that.
I have a question for you.
Yes, go ahead.
Should we use what the packet says? Because I know the packet on the back of it, it says it dissolves in about 8 ounces of water or 16 ounces of water. So wouldn't that be like the more relative thing to use so you get a nice control? Because the packet's saying use this amount of water to dissolve it in. So wouldn't it be more like saying it's made to dissolve in this amount of water?
Yeah, so what do they actually say? I'm just looking at it. I'm just curious. It says place 2 tablets in 4 ounces of water. Okay, so that's
what mine
about
says, too.
120 mils, right? Ounces, remember, about 30 mils per ounce. But here's the problem with us deciding ahead of time exactly how much water is what if the 2 cups that you have are kind of small and 100 mils of water would be too much water to put in it. I actually think that the most important thing here is not how much water, the actual amount of water that we use. The most important thing is that we use the same amount of water so that we have, not that we all use the same amount of water, but that we don't use a different amount of water in this container and this container. These have to be the same. I think that's the most important thing that we do, because I don't know, it's not like we have, if we were in a classroom, we'd all have 250 beakers and we could just go, okay, here's what we're going to use. But I will tell you that even in my classes where I've done this before about 100 times, I always let the groups decide exactly how much water that they would use. And is it possible that the amount of water affects the dissolving of the Alka-Seltzer? It is possible. I'm not saying it isn't. But in this particular experiment, I think the most important thing we want to pay attention to is how that we have the exact same amount of water in both containers. We're not dissolving the warm in 100 mils and the cold in 30 mils. That's the most important thing here. Now, again, you know, the reality is that when I was a kid and I was taking this Alka-Seltzer, I'm going to tell you that 4 ounces of water, the big deal really, when you were delivering this to your body, the biggest thing was to get it down your throat before you threw up, right? And so my mom would use a glass that was not a shot glass, but it was definitely, well, it could have been about this big, but she would only put about this much water in it, because then the pill goes in, it dissolves. Once the pill was dissolved, it would be like, okay, drink it and try and get it down, because honestly, it doesn't have a great taste, and it's bubbly and fizzly, and it's whatever. So I know my mom never cared about the 4 ounces of water. She just cared about putting it in enough water so it would be completely dissolved, and that you could then choke that amount of water down. So, I mean, I'm not trying to discount the idea that we could, if under the right circumstances, we might all decide we're going to use this exact same amount of water. The problem is that I don't really know exactly what kind of containers people have. I'm not saying go out and buy pair of new wine glasses to use for this. I mean, one person may find 2 identical wine glasses and do the experiment in those wine glasses. Somebody may find, you know, that they're using a little plastic glass. Some are using a glass like this. And so that's why I'm saying it would be good for you to put the appropriate amount of water in, whatever that is, okay? So could this be a weakness in the experiment? It could be. And so just as a note, look, way down at the very bottom here, it says, what are some weaknesses in this experiment? There's a place to put down a concern that you have, that it wasn't, you know, that maybe you should have used the same amount of water that the Alka-Seltzer tab, you know, that was on the box or whatever, okay? Oh, why did I go away from that? I'm going to go back to it just for a minute. And really, we've done a lot of good work here today, okay? Done a lot of good work here today. I'm going not to lose this document. I'm just going to move it down here, okay? And I'm going to go back to here, okay? Now, I kind of boomed through this, so let me make sure that I'm going to go to this slide here again. Step number 2, we did this. We did this when we looked at Alka-Seltzer and we watched Alka-Seltzer dissolve. We were reviewing the literature. Now, you notice I put the word literature in quotes. In the olden days, when I was an undergraduate, it wouldn't have been put in quotes because there would have been not that many things you could have consulted. But nowadays, it's important for me to point out that there's the sort of standard historical primary literature, and then there's the good old secondary literature, which is just about everything else. And that could include, and of course, in my mind, it would include Google. I mean, look, I study bobcats at the U of A, and when I have questions about bobcats, I will often Google. I'll stick that exact question is, you know, what is the average lifespan of a bobcat? Well, I'm not going to do any research about that. I'm going to Google it and find out about 27 other people who have already studied it. And I'm going to find the answer. I'm not going to have to go out here in the desert, or at least I wouldn't choose to go out here in the desert and start capturing bobcats and pulling one of their teeth out so I could estimate their age. I wouldn't do any of that. I would Google it because somebody else has already figured that out. And that's why we live in wonderful times. I mean, I think in the future, they're going to look back and they're going to say, okay, you lived in PG or AG. You know, it's going to be, did you live pre-Google or after Google? Because there's such a profound change in the nature of the world of literature and information as soon as things like Google and other search methodologies came into effect. I mean, I don't think I used Google first. I'm trying to remember what the very first search engine I ever used was, and I don't think it was Google. But anyway, so are there any questions about this, the second step, the reviewing the literature stuff that we do to, our goal is to try and understand the research question better, but look at this question down here at the bottom. Why do we do step 2? Why do we do step 2? Number 1, it's because there are 7 steps in the scientific method. We need to do them all in most cases. I mean, we do every step. We don't decide to skip a step. Now, you know, if you go on to become a scientist, which there's always that possibility, you know, there are nurse researchers that work at the U, and they do research all the time. You know, that they're nurses, but they're working in a research setting and they're testing drugs or amazing sorts of stuff. One of my previous wives was a nurse researcher, and I mean, she used to come home every day and tell me these crazy, amazing stories about the research work they were doing over at the U. So number 1, we do step 2 because there are 7 steps and it's step 2. Number 2, this is important because when you do step 2, you might actually find the answer to the research question, then you'd be done. I mean, again, if I had a research question like, are cats smarter than dogs? I might Google that and find some studies in which this has been carefully studied, and I might read those studies and decide I don't agree with them. Or I might read those studies and decide, wow, I totally agree with them. I don't need to do any research on this. I got the answer doing step number 2, and I'd be done. Right? Step number 3 is also critically important because when you do step 2, you gather important knowledge and insight that helps you do step 3. And step 3 is where you create hypotheses much better because you gather knowledge and insight that helps you do step 3 much better. These are all important reasons why you take the time to do step 2, okay? And again, you don't skip steps. There's 7 steps. You might find the answer and then you could be done, or maybe then you could move on to something, an extension. You know, like if you ask the question, well, is the average weight of bobcats the same in the southwestern bobcat population compared to the northeastern bobcat population? You might think, well, I guess what I'm going to do is write a grant, weigh a bunch of bobcats here, weigh a bunch of bobcats there. Or maybe you do step 2 and you find out, oh my gosh, it's already been done 5 times. Here's the result. Bobcats in the Northeast are heavier, and it is a statistically significant difference than bobcats in the Southwest. Well, I could go, great, I don't have to do that experiment, but then I could move on to the second part and go, well, okay, now my next question is, why are they heavier in the Northeast than the Southwest? I can move on to a higher level question, okay? So, what is step 3? Step 3 is create multiple hypotheses to make a list of possible answers to the research question. Look, the best definition of a hypothesis that's out there is this definition. And I am picky about it. It's certainly One of those things I will ask you about. A hypothesis is one of the many possible answers to the research question. Remember, this is my 6th grade science teacher quoting through me. My 6th grade science teacher said, for any question that you have, there are always multiple possible answers. Any question has multiple possible answers. Really, I can't hardly think of any question that doesn't have multiple possible answers. I mean, one would be like, look, should we have spaghetti for dinner? One possible answer is yes. One possible answer is no. One possible answer is, well, we had spaghetti last week. I mean, there's multiple possible answers. A hypothesis is just one of the many possible answers to a research question. Now, I'm going to tell you what I think is one of my least favorite definitions of a hypothesis. And believe me, I read it. Is this definition of a hypothesis that says a hypothesis is an educated guess? I know people have heard that definition before. I've read it many times, okay? Here's my problem with educated guess. Number one, it doesn't really tell you what it is you're guessing about. It doesn't really explain what educated means. I mean, what is a guess? Exactly what does guess mean? Look, if you defined a hypothesis as an educated guess about the possible answers to a research question, I would be fine with that. But the 2-word answer, a hypothesis is educated guess, it's just feeble to me. And I'm going to admit to you, I've been studying the scientific method for many years, and I've always thought educated guess was one of the least useful, in fact, confusing definitions of a hypothesis. A hypothesis is one of the many possible answers to a research question. Now, notice up here it says hypotheses. Create multiple hypotheses, because you'll never just generate one hypothesis. You'll really generate as many hypotheses. You want to make a list of possible answers to the research question, and a hypothesis is one answer on that list. Now, here's something important. It could be a great answer. It could be an awful answer. It could be a stupid answer. But it is a hypothesis nevertheless. But I'm going to show you very soon how to take a hypothesis and analyze it in a very basic way to decide if it belongs on the list or not. Okay? I want to mention that hypotheses tend to be general and they tend to apply to many cases, and I'll try and give examples of what I mean by that. But sometimes the example that comes to mind for me is I could have a research question like this. What are the laws of gravity? And somebody generates a hypothesis. What goes up must come down. Pretty vague. It says what goes up must come down. It's general. It applies to many cases. You could then give examples and say, well, if what goes up must come down, then when I throw a pen up in the air 27 times, it will fall down 27 times. Now I'm doing a prediction about something countable, measurable, and weighable. It is best to start with a long list of hypotheses and hope that the best answer is somewhere on that list, because it may not be. I mean, you could create a list of hypotheses and start testing those hypotheses and throw them all off the list and go, guess what? We're back to square one. There's no more hypotheses on our list. None of them were able to withstand critical thinking and testing. And so now we have to go back and start thinking of more hypotheses. When you make a long list, what you're hoping will happen is that you'll get some good hypotheses on that list, ones that will live on the list for a while, ones that will make true predictions, ones that are valid and testable, and those kinds of things. But part of the price you pay for creating a list of hypotheses is that you hope you're going to get some great answers, some of the best answers, but you're likely to get some answers that are, not good answers. And that's just the price you pay for trying to create a big list. Any questions about the hypothesis stuff that I've put out here now? I'm happy to answer any questions anybody has. I mean, look, I know I am being a pain about this, but you're going to appreciate it later. When somebody asks you what a hypothesis is, and you say, look, a hypothesis is one of the possible answers that you have to a research question. It's part of the scientific method. Having a good definition for a hypothesis is a very good thing, because there are lots of bad definitions for hypotheses out there. And you know what those bad definitions do? They just mess with your whole they mess with your procedures, that's all. Because you don't really know what you're supposed to be guessing about. Again, I'll say it, if you said a hypothesis is an educated guess about the possible answers to a research question, I'd be fine with that. Because at least I understand what I'm guessing about. And the educated, in my opinion here, when you say educated, it means you've done step number 1 and step number 2 well enough. Okay? Okay, we're still in hypotheses. So let me ask this question. What are the properties of a good and a useful hypothesis? Right? Well, let me tell you some of them. One is a useful hypothesis is valid. This means it actually answers the research question. It makes logical sense. It accounts for the known facts. Hypotheses need to be logical. They need to account for things that you already know, and they need to actually answer the research question. Believe me, when you make a list of hypotheses, you'll find hypotheses creeping on that list that don't actually answer the research question. I remember my 6th grade science teacher, he pointed at the door of our classroom and he said, "Is it day or night out?" Question mark, is it day or night out? The one possible answer clearly is it's day. One possible answer is it's night. One possible answer is it's dusk, right? Which is sort of between day and night. Another possible answer is it's dawn, which is between night and day. Another possible answer is it's always darkest before the dawn. Another possible answer is I'm afraid of the dark. Another possible answer is, you could make a list of possible answers, but look, I'm afraid of the dark. That could show up on your list, but is that valid? Does it actually answer the question? No. Doesn't really make sense. It doesn't answer the question. How about that statement? Oh, it's always darkest before the dawn. Well, it sounds like it has something to do about day and night, but did it answer the question? Is it day or night out? No, it isn't valid. That's how we throw it off the list. Number 2, a useful hypothesis is testable. That means you can use it to generate predictions about measurable, countable, weighable world. Look, remember what I said about the scientific method? It is designed to work in the measurable, countable, weighable world. If you can't measure, count, and weigh things, you probably can't use science as a tool to answer your questions about it, right? A question like, are bobcats heavier in the Southwest than they are in the Northeast? That sounds countable, measurable, weighable. I'm not going to say it'd be easy to get this data, but it would be countable, measurable, weighable. A question like, why does my girlfriend ignore me these days? I'm not really sure that you're going to be able to do science around that. What is the meaning of life? I don't think you're going to be able to do science about that. Just like I said the other day, anytime I hear about anybody wanting to do scientific stuff around love, like, does my boyfriend love me? Well, that's a research question, I agree, but I'm not sure how you would do science on it, because there's no way to measure love right now. As far as I know, there's no love-o-meter. You know, there's nothing like that. Thirdly, a useful hypothesis is falsifiable. That means you can show that it's made a false prediction and the hypothesis can be rejected or disproven. I mean, a hypothesis, if you can't demonstrate that that hypothesis is false, that it has made false predictions, then that hypothesis is useless, and you should throw it off the list. That's what it comes down to. Let's say you have a long list of hypotheses, and you go, all right, is this hypothesis valid? Yes. Is this hypothesis testable? Yes. Can we test this hypothesis and see if it made a false prediction? Yes. Well, then that hypothesis gets to live another day. But if you look at your list of hypotheses and go, what about this hypothesis? Is it valid? Well, no, it doesn't even answer the question. Well, it gets thrown off the list. Is it testable? I mean, that's the thing. Can you test if somebody loves you or not? Can you generate predictions about measurable, countable, weighable things that are going to demonstrate whether someone loves you? I'm going to say no. Because as important as love might be, it might be what gets you out of bed in the morning. Right now, it's not measurable, countable, weighable. And so if it's not measurable, countable, weighable, then you can't use science to answer that question. You can go the flower route, you know, she loves me not, she loves me not. You can get a Ouija board. Okay, maybe some people put a Ouija board in their toolbox and they go, okay, I'm going to ask the Ouija board, does my boyfriend love me? Oh, no, it went to N, it went to O, oh, no. But that's not science. That's Ouija board, okay? The thing is, science is just one type of tool. There are many other types of tools. I said this in the very beginning. Science can't answer every question that you have. It probably can help you answer questions about measurable, countable, weighable things. Sometimes you have to invent devices to measure things. I've had to do this. When I was a marine biologist and I worked, I had a research question about something that I thought was measurable, but the devices to measure it didn't exist, so I had to invent those devices. And even then, people said to me, well, you know, I'm not really sure this device is actually, you know, it's actually measuring what you want to measure. But most of the people who looked at it did agree that it was measuring what I wanted to measure. So sometimes you have to ask, is there a way to measure this that just doesn't exist yet?
So I have a quick question real quick.
Oh, take your time. I'm happy to answer questions.
So on thought question G, this is on there and it said describe 2 properties of good useful hypothesis. And on here on the slideshow, there's 3. So I was wondering if that was a typo or do we pay attention to 2 of them more? I don't know. I was just curious.
Well, good. No, thank you for asking that question. Here's what it is. It's not a typo. It's just me saying, tell me 2 properties of a good or useful hypothesis, even though I've given you 3. Right? That's all. I've just given you 3 properties of a good or useful hypothesis, but I'm only asking for 2 just because, I don't know. You know, to be honest with you, it's very rare that I have a question like, give me 6 examples of a positive feedback loop. I'm usually going to go, give me 1 example, give me 2 examples. So I'm not suggesting that you wouldn't want to know all 3 of these. But if I put that question on a quiz and I said, tell me 2 or describe 2 properties of a useful hypothesis, you would just choose whatever 2 of these you remembered or you liked.
Okay.
Okay, thanks.
Yeah, good. I'm glad. That was a great question. Thank you for asking. I just, you know, again, I might have a list of 7 things, but I'm very unlikely under, you know, short answer kind of question experience to go, tell me 7 or tell me 6. I would say, you know, tell me 2 examples of this. Like, I'm going to give you some different chemical reactions you need to know about. I'm going to have to say, look, give me one example of an anabolic reaction, one example of a catabolic reaction, even though I might have given you 7 examples of each. So that's what it comes right down to. So these are the 3 major properties. And what's useful about this is this will actually help you throw hypotheses off the list. So you can sit back and relax and generate a whole long list of hypotheses. Great. That's what you want to do. And then you're going to say, okay, here's our list. Let's go through the list and see if any of these hypotheses can be thrown in the trash right away because they're not valid, they're not testable, they're not falsifiable, right? And most of the time you will be able to throw hypotheses off the list because they aren't valid, they aren't testable, they aren't falsifiable. Okay, so look, I need to take a break, just stretch my legs. I'm sure you do too. I'd like to talk about this, why won't my car start question, and then, but I got to get up and got to move around a little bit. My legs are, well, let's put it this way. One of my legs is so numb, I'm hoping I'm not going to fall over when I get up. I'm going to get myself some more soda because I need more caffeine, and I'm going to drink some Alka-Seltzer. No, I'm only kidding. We're going to take a 10-minute break, and when we come back, we're going to think about this question, why won't my car start? So if you don't have anything else to do during the break, I want you to think about cars. And I wonder if you've ever had this research question, why won't my car start? Okay, 10-minute break. I've lost the smooth jazz, so you're just going to have to listen to nothing. But I'd really rather you got up and did some jumping jacks and moved around and got some more caffeine and all that kind of stuff. Okay, 10-minute break. I'm back.
Hello.
Anybody still here? Look at that. Oh my gosh. There's 21 people here. I really appreciate it. So the bottom line is that I am going to continue right where I left off. I wanted to. I was hoping people might think about this question a little bit, and so the research question is, why won't my car start? And I don't know. I'm sure everybody has had this experience where, you know, they're on their way to work, they're on their way to class, they go out, they put the key in the ignition, they turn the ignition, the car doesn't start. Now, I am positive that when that happens to you, this research question pops into your mind. Why won't my car start? So if you're doing the scientific method, and believe me, you can absolutely use the scientific method to try and help you answer this question. This in my mind, this mostly makes me think of measurable, countable, weighable things. But let's work our way through it. So step number 1 was create a research question that is as clear and precise as possible. And this one does seem like it's pretty clear. I mean, we most of us know what a car is. We know what it's looks like, sounds like when it starts and when it won't start. So then we move on to step number 2 in our mind. And when we go into step number 2 in our mind, we're really asking ourselves, what do I know about cars and how they work? This is where you sort of, you pour through your extensive knowledge of cars and how they, what makes cars run and what makes cars not run, etc. And then within seconds, usually, you move on to step 3, hypotheses. And you're saying, look, my car won't start because, and you're gonna make a list of hypotheses. So let me just ask, can somebody tell me one hypothesis about why your car won't start?
The battery died.
Okay, the battery is dead. Good one. I mean, that's definitely one that should be on the list. Another one. Somebody else. Tell me another one.
You don't have any gas. Yeah, out of gas. That's a good one too.
Okay, car's out of gas. Another one. Another one. Another good one. Another reason why it might not start.
Your radiator overheat.
Okay, your radiator overheated. Another one.
The key's broken.
The key's broken. Great, thank you. Another, you could even say, well, I'm not using the right key. I mean, I have 2 cars with pretty similar keys. I don't know if I could. I know if I was able to stick one key in the wrong car, it certainly wouldn't turn the ignition. So can anybody think about any other ones? Any possible answer to why your car won't start? I mean, everybody's pretty pragmatic in this group. But so let me just show you a list that could be generated for this. Number 1, it's out of gas, right? Somebody mentioned that one. Number 2, the front left tire is flat. Number 3, the oil level is a little low. Number 4, the battery is dead. Number 5, the battery wires are damaged by pack rats. Number 6, I was rude to my mom, and this is car karma, etc. Right? I mean, the truth is that you could probably list a lot of possible hypotheses. That's all these are. Now, when you look at this list, do you see any hypotheses that are probably pretty good hypotheses?
Yeah.
Sure, there are good hypotheses here. And then there are what I would call weak hypotheses, and then there are stupid hypotheses, right? I mean, I'm going to say that I don't really believe in I don't believe that because I was rude to my mom, that's going to prevent my car from starting. But I'm not unhappy that I have it on the list. I'm not unhappy to have it on the list. Remember, when you generate hypotheses, it's best to have a long list, and then decide what hypotheses deserve to stay on the list and what hypotheses don't deserve to stay on the list. Now, sorry, I got to do this. I'll be right back. Okay. I forgot what slide was next. I'm trying to think. Okay, was there more hypotheses? No, there wasn't. So look, let's look at this one. Let's just look at some of these hypotheses. Number one says it's out of gas. Now, that does answer the question, right? My car won't start because it's out of gas. Is it testable? I mean, can I somehow figure out if it is in fact out of gas?
Yes.
Sure. And is it falsifiable? Could I discover that there was plenty of gas in it?
Yes.
Sure. So you see what I'm saying is that the hypothesis that it's out of gas is valid, testable, falsifiable. How about number two? The front left tire is flat.
Yes.
Now, number one is it? I'm going to go backwards. Is it falsifiable? Could you find out that the flat tire, the fact that the tire was flat, would cause? No, I'm sorry. I'm going to go backward. I didn't want to go backwards. Number one, is it valid? Does it answer the question? Does it make sense? And does it account for what we know about cars? And I'm going to say it's not valid. Right? Why do I think that the fact that the front left tire is flat isn't a valid hypothesis?
Because there's nothing to do with the engine.
I agree with what you just said. Because, look, in my experience with cars, the fact that you have a flat tire, I mean, it doesn't really have any impact on whether you can start the car or not. Though, I have to tell you, these days with computers, it wouldn't surprise me. It really wouldn't surprise me if somebody decided, look, we're going to set it up so if the tire's flat, the engine won't start. But let's pretend there isn't somebody, doing that. I think the fact is that you can have all four tires flat and the car would still start. There's virtually no relation. It doesn't account for the known fact that a flat tire won't prevent you from starting your car. So guess what? I'm going to throw number two off the list. Because it isn't valid. And if it's not valid, it doesn't make sense. It doesn't account for the known facts. The fact that it answers the question is great, but it doesn't really make any sense. Just like number three, right? I mean, number three, the oil level is a little low. Well, I do know that oil has something to do with cars. I'm not a car expert. I do know you need to have a certain amount of oil in it. But I mean, if everybody's car wouldn't start because the oil level was a little low. I mean, I'm just talking about a little low. I'm not saying you're out of oil. Maybe another hypothesis would be, my car won't start because the engine is completely out of oil. That's another hypothesis I could have put on the list. But if it's 3/4 filled, then that's not going to affect whether your car starts or not. It just doesn't make sense. So I'm going to say number three gets thrown off the list. How about number four? Is it valid? Does it answer the question? Does it account for the known facts? Does it seem to make sense under these circumstances? I would say yeah. Is it testable? Could we somehow do something to discover if the battery's dead? Well, I would call AAA, but you could get a battery tester. And is it falsifiable? Could you do a test and discover your battery is fine?
Yes.
Sure. So number 1 stays on the list. Number 2 gets thrown off. Number 3 gets thrown off. Number 4 gets to live on the list. How about number 5? Battery wires are damaged by pack rats. That's not the same as the battery dead. It just, I mean, honestly, this is sort of a common thing in Tucson, right? Where people can't start their car, they go out and they realize, oh, I see, the pack rats have literally nibbled through the wires. So what about number 5? Is it valid? My car won't start because the battery wires are damaged by pack rats. Is it valid? Does it make sense? Is it possible that this is true? Sure, it is. So I would say number 5 was valid, testable, and falsifiable. Number 6, I was rude to my mom, and this is car karma. Well, you know, I threw that one on because it was just plain silly. I mean, aside from the fact that it doesn't seem to make sense to me that there's any relationship to how I treated my mom and my car not starting, unless my mom went out there and unplugged something, right? But I'm referring to something called karma here, and I'm going to say that even though this is an answer to the question, it doesn't really seem to make sense to me. It doesn't account for the fact that there's tons of people out there with bad karma, their cars run fine. And beyond that, even if I decided it was valid, then how am I going to test this? Is there some way I can measure karma? Can I measure rudeness? Can I call I guess I could call my mom and go, Mom, please forgive me. And now I'll try my car. Started right up. Okay, great. But let's face it, number 6 is in the category of not testable. So it gets thrown off the list. In the end, we end up with this hypothesis, and this hypothesis. Could there be additional hypotheses? Could there be additional hypotheses?
Definitely.
Of course. I mean, honestly, there could be hundreds of hypotheses, and 96 of them could be just plain stupid. Right? I mean, you could have a thing that, well, the reason my car won't start because aliens have taken over all the electromagnetics of the entire world, and nothing starts anymore, right? I mean, whenever you make a list of hypotheses, you always are, it's always possible that when you generate the list, it is going to include bad hypotheses. And when I say bad, I mean not valid, not testable, not falsifiable. That's what I mean by bad, right? And I mean, you know, a silly hypothesis is one that is one that it just, you know, it falls in the not valid category. So look, let's just for a minute say, all right, the first hypothesis was it's out of gas. Hypothesis 1, my car won't start because it's out of gas. Can somebody suggest a way that we could test this hypothesis to see whether it makes a true prediction?
Look at the gas tank.
You could do what?
Wait, are you asking how to test number 1?
Yeah, exactly. How can we test it?
Look at the gas tank.
Okay, so you could get a stick, which I've done, and you could stick the stick down in your gas tank and pull the stick out, and if there is no gas on the end of it, you could go, oh my gosh, it seems like my gas tank is empty. I totally agree. That is a way to test it. What other ways could you test if it's out of gas?
Just start up your car.
Is do what?
Just start up your car or look at gas level meter.
Oh, exactly. Just look at the gas gauge, right? And if the gas gauge is pegged out below E, well, then you go, oh. So literally you could go, look, if the reason my car won't start is because it's out of gas, when I look at the gas gauge, I am going to discover that it is way below E. And that is going to support that hypothesis. Another
Also,
way, go ahead.
Also, too, there's another way if you want to sub out number 5 for being damaged by pack rats. The heat of the sun can also damage your battery too. If it's too hot, you don't have under shade,
Sure.
it will deplete your battery. If it's like, because I'm from Yuma, Arizona, and sometimes that does happen where it's 120 degrees for like 2 weeks on and your battery's just dead.
Yeah, no, that happened to me just 2 weeks ago. That happened to me 2 weeks ago. My car was fine. I turned it, went out and started it. But let's just go back to the out of gas thing for a second. Is there another way that we could determine whether the being out of gas hypothesis might be the best one? And what comes to mind for me is, because I've done this before, of course, is I buy some gas, I put it in the tank, and then I see if it'll start. Right? I mean, the bottom line is that are all of these possible? Could you look at the gas gauge?
I have another thing.
A gas tank. What's another one?
Your gas could be full, but it could be bad. Because you have one of these new hybrids, you don't drive them around, the gas will go bad in it. So you could have gas, right, but it's gone bad.
Right. So that seems to me like another hypothesis, right? That another one is my car won't start because the gas that's in it is bad gas, right? I mean, so the point is, when it comes to hypotheses, one main point that people don't necessarily understand about science is you generate these hypotheses. You try and generate as many as possible. I mean, because you know what could happen? You could look at every hypothesis you have and decide that they're all bad and throw them off the list. I mean, that happens. All of them are bad. They're all off the list. Now what do? We don't give up on science. We think, okay, what hypotheses did we miss? That's why I tend to say, look, generate a long list. The longer the list is, the better, because you hope that on that list there's, then it is, you'll hope that on that list there are good hypotheses, ones that are valid, testable, falsifiable. Go ahead.
I was just wondering, could you like use one hypothesis to check the other? So like, you think it might be out of gas, but you don't have a way to. Well, never mind.
You don't have a way to test it. Well, I mean, it's possible that you have a hypothesis that's difficult to test. Now, with it being out of gas, I'm trying to think of if it was out of gas, and I think the first thing I would look is at my gas gauge and go, uh-oh. Then I'd put a stick in the tank if I could and see if there was any gas residue on it. Then I would take my other car, fortunately, and go buy some gas and put it in it. Or I guess I could siphon some gas out of one car into the other car. And if all of those, if I did those things, let's say I looked at the gas gauge and it was actually said that there was plenty of gas, it was full. Well, then I would tend to think, well, that hypothesis predicted that the gas gauge would be below empty, but it isn't. It looks like there's plenty of gas, and I kind of trust my gauge. So I think this hypothesis made a false prediction. And once a hypothesis makes a false prediction, we wave bye-bye to it and take it off the list, which is great. You know, one thing about science that's really good, science helps you take a long list and shrink it down. And hopefully what you're going to eventually get is closer and closer to the best answer. Okay? Now, again, number 4, let's say we discovered there's plenty of gas in it. Well, we already got rid of 2, 3, 6. And so we're on number 4, the battery is dead. My car won't start because the battery is dead. Well, is there a way to test that? Of course. You could, it's possible that right on the control panel, there's a light that tells you the battery's dead. You could say, if the battery's dead, then when I turn the key to the on position, it's going to show a battery, a lit up battery on the control panel. What's the word I'm looking for here? Not necessarily control panel, but anyway. So, or I could go ahead.
Let's say it's you're doing a hypothesis and it's the battery, but let's say it's not the battery. Let's say it's the spark plug, the wire, the sugar cap. It's something that branches off from the battery. It's not the battery per se, but it leads out into like a root tree type thing. Like it's still connected to the battery, but it's like a branching thing from the battery. It's the wires, it's the connection, right. It's like a branching thing, but it's still all considered into the battery.
Right. Well, I would be inclined to list that as a different hypothesis, right? So I would say one hypothesis is just that the battery's dead. I mean, the battery has failed, it has died, and that's the fundamental reason why the car won't start. But then, as another hypothesis, well, that's why I put here the battery wires are damaged by pack rats. You could put another hypothesis. The spark plugs are so fouled that that's the problem. The spark plugs are broken. That's the problem. The distributor cap is, I mean, let's face it, you could create a pretty long list if you know, sort of basic stuff about a car. You could do, I mean, on this list, you could go, my car won't start because the computer is fried. I don't know what the real technical word is, right? But I certainly know I've had a car that wouldn't start because the computer failed. Everything else was fine, but the computer failed. So I could have put that on the list too. But to be honest with you, my limited experience with cars, when a car won't start, I would say the most common reasons it doesn't start is because it's out of gas, the battery's dead. If I was to determine that both of those were, that it is got plenty of gas and then the battery is fine, well, then I would have to go, these two hypotheses made false predictions. I think I need to generate some other hypotheses. And again, I'm going to tell you, a long list of hypotheses is better than a short list of hypotheses. So, you know, the battery wires are damaged by pack rats. That's easy to test, right? My car won't start because the battery wires are damaged by pack rats. If that's the best hypothesis, then when I open the hood and I look at the wires near the battery, I'm going to see damage to those wires. You see what I mean? The point is that I'm trying to illustrate that. Look, this is a very practical, normal question that somebody might ask. Very practical, normal question. And can we use the scientific method to answer this question? Yes, we can. Right? We can use it. We can go from hypotheses to predictions to analysis. And the other side of this is, I really want to say, don't we already do this? Isn't this a normal part of our thinking process? We generate hypotheses. I mean, look, if let's just say you look at your watch and you go, wow, it's 6:30. Why isn't my wife home now? You know, assuming she's normally home. I mean, do you just go, I wonder why my wife's not home now, and then move on to something else? Or do you start generating hypotheses like she's not home because she had to work late. She's not home because she decided to go to the store on the way home. She's not home because her car ran out of gas. She's not home because there's a huge amount of traffic today. She's not home because she's left me for another man. She's not home because she forgot where she lives. She's not home. You see what I mean? I could generate a long list of hypotheses to explain or to answer the question. It's 6:30. My wife's normally home by 6:30, but she's not. Why isn't she home now? I mean, I could say, you know, it's because she was kidnapped by aliens. It's because she is shrunk down so tiny she can't drive a car anymore. Now, I'm just telling you that when you do make a list like that, I guess where I'm heading with this is, don't we all do that? Don't we automatically do that? You know, why don't we generate a question, we generate a question, then we generate hypotheses. You know, I come home and my porch light isn't on, and I always leave my porch light on. I've got kind of a dangerous porch, and so I leave my porch light on. It's an LED light, at least 24/7, just in case. Well, I come home and I getting out of the car and I see that porch light's not on. I go, well, why is my porch light off? Okay, here's hypothesis one. All the electricity in my house is out because I forgot to pay the electric bill. Someone accidentally turned, another hypothesis, even though we leave this light on all the time, it accidentally got turned off. Another hypothesis, the light bulb finally burned out. It's been in there for 5 years. Another hypothesis, all the electricity everywhere in this area is out. You know what I mean? You start generating hypotheses. I just want to impress upon you the idea that this is an extremely normal thinking process that you already do. Okay, it's what you already do. And so you, of course, can use science in your normal lives and we already do it. We just don't, maybe we just didn't know the terminology about it, okay? So great, thanks everybody for jumping in there and you know, participating and giving me some good answers here. All right, next slide. And I don't know about you, I feel like I'm running out of energy. So I might not go to 5:35 tonight, but we've covered a lot of material, and there's that quiz out there. I'm hoping people will go and take a look at that quiz and maybe even start working on it. You know, again, because of the scenario we're in, I'm allowing these quizzes to be open note, open book, and some of the questions are clearly going to be completely answerable by looking at all the material I've managed to present there. All right, so here's some famous and important hypotheses to consider, which we need to know about because these are absolutely part of the scientific method. The first one, very famous, is a hypothesis called the null hypothesis. And I abbreviate, as many people do, the null hypothesis this way: capital H for hypothesis, sub-zero, because null means zero, no difference, no relationship, no change. Now, you can apply the null hypothesis to the car thing. Absolutely. Uh-oh. Timer's going off. Give me 1 second. Sorry, folks. I was boiling some eggs. And I was afraid they were going to like overboil or something like that. So I had a little timer in my pocket for a half hour there. Anyway, sorry, back to the null hypothesis. The null hypothesis always says there's no difference, no relationship, no change. Here's what I mean. Remember the question, are cats smarter than dogs? Well, the null hypothesis will say, no, there's no difference in the intelligence of cats and dogs. Are women taller than men? The null hypothesis always says the same thing. Nope. Nope. There's no difference in the average height of women and men. Are bobcats heavier or is there a difference is there a statistically significant difference in the average weight of bobcats in the Northeast and the Southwest? Guess what the null hypothesis is going to say? Nope, no, there's no difference, etc.
I have a question for you.
Yes, go ahead.
Did this hypothesis come up first, or was it Schrodinger's cat? The cat is alive and dead in the box. Until you open up the box, you won't know the answer. So at both points, you have to assume that it's alive and dead. Is this a scientific thing, or is this more of a philosophy thing type exercise?
Well, I think that
that whole issue.
Yeah, right. Well, the Schrodinger's cat thing is kind of sort of like quantum physics thing, right? Where if the cat's in the box, you cannot see or observe the cat or gather any data about it. You just don't know, is it dead or alive? It could be dead, it could be live. There's equal kind of possibility there, right? So at least in some kind of quantum physics philosophical realm, it is either alive or dead, or maybe both alive and dead at the same time. But I think that if you had a question like that, it would be difficult, though not impossible. I might need to just think about it to apply this kind of hypothesis to it. What this is a standard part of scientific method, and a really important part, because every statistical test that helps us answer questions like this is very dependent on the null hypothesis, because a statistical test will basically tell you, in almost all cases, whether you should accept the null hypothesis that there is no difference, no relationship, or no change, or you should reject the null hypothesis and say there is a difference, there is a relationship, there is a change. Now, I don't know if the null hypothesis was the first hypothesis anybody generated, but I think that it arose as an important hypothesis as people studied the scientific method and hypotheses and realized that, hey, out there's always this one hypothesis, the null hypothesis, that there's no difference, no relationship, no change. I don't think this can be applied to the sort of quantum physics universe in which Schrodinger's cat is definitely alive, because I don't really like to think of dead cats.
Well, Schrodinger's cat's a completely different subject. It was basically, according to Wikipedia, it was devised to prove a point about illustrates the problem of something being applied to everyday objects, that in quantum mechanics, basically you can assume that two different states apply to an object at the same time.
Right.
But from what it says, so that the null hypothesis is basically saying that it's always an option that your hypothesis is just wrong or doesn't apply. I'm not sure how to say it right. Is that correct?
I wouldn't use the word doesn't apply. In fact, I really would. I think that from a
or as
sort
you
of,
said, that there's no relation.
What it says is, yeah, it's better. I think the best way to envision this for understanding purposes is just that whenever you generate hypotheses, which you will, that there's a possibility that one of the hypotheses that you need to generate and consider is the null hypothesis. Now, I'm not sure that you can apply the null hypothesis to the question, why won't my car start? Right? Because that very basic question, I don't think there's a null hypothesis that says the reason your car won't start is because there's no difference between your car starting and not starting. You see what I mean? So I'm just trying to create for you a list of hypotheses that you want to consider whether they should be applied in a particular case. And I think that's the best way to think about it. There certainly can be situations in which you won't use a null hypothesis. But let's just consider the Alka-Seltzer experiment for a minute. Will Alka-Seltzer dissolve more quickly in warm or cold water? What would the null hypothesis be for that particular question?
That it dissolves in the same rate in both?
Absolutely. That there is no difference in how long it takes to dissolve. There's no relationship between temperature and time to dissolve. You see what I mean? Now, look, I said no difference, no relationship, no change to make this pretty broad. But the bottom line is that I can see how you would say there is no difference in how long it takes for Alka-Seltzer to dissolve in warm water and cold water. There's no relationship between the temperature of the water and the time to dissolve. There's no change that you will notice when you gather this data because you're going to get essentially the same number for warm and cold, right? So that's just one. So we're going to put this as the null hypothesis remember what I'm calling this, famous and important hypotheses to consider. Then there's alternate hypotheses. And alternate hypotheses are hypotheses that are not the same as the null hypothesis. And usually, see, there's only one null hypothesis. It says, look, no, there's no difference between the time it takes to dissolve in warm and cold water. Alternate hypotheses, usually there's lots of them. I've got H sub 1, H sub 2, H sub 3, H sub 4, H sub 5. I mean, I could have listed this when we did the car thing. Usually there's many of those. And every alternate hypothesis is going to start by saying, oh, there is a difference and a relationship, a measurable change. Because remember, the null hypothesis says no difference. There's no difference. Doesn't make any difference what you're asking me about. You know, are women taller than men? Nope. There's no difference. There's no relationship between sex and height, etc. But alternate hypotheses will say things. Usually, they will say, "Oh yeah, there is a difference." Like, for example, if we used a question like, "Are women taller than men?" Well, one alternate hypothesis would say, "Oh yeah, there is a difference in the height of men and women are taller." But what's another hypothesis that could be applied in this same case? I mean, one hypothesis was there's no difference in the height of men and women. One says, oh yeah, there is a difference and women are taller. What's the other one? I mean, somebody's thinking it. I know, I can read your brain. Somebody's thinking this. Well, the other hypothesis says, yes, there is a difference in the height of men and men are taller, right? Now, could there be an alternate hypothesis that says something like this? Women seem taller because they always stand up straight. Or it's another hypothesis would be we can't measure the height of men and women because they're way too tall. I mean these are silly hypotheses, right? But in the case of a question like the Alka-Seltzer question, let's say, because that's one of our favorite questions now, null hypothesis says there's no difference in the time to dissolve in warm and cold water. What is one alternate hypothesis? Everybody is asleep now, that's why. An alternate hypothesis, remember the first hypothesis was there is a difference in the time to dissolve. Sorry, first hypothesis was there is no difference in the time to dissolve in warm and cold water. What's one alternate hypothesis?
that there is a difference and it is quicker in hot water?
Absolutely. Perfect. The one alternate hypothesis says, oh yeah, there is a difference and it will dissolve faster in warm water. Okay, what's the another alternate hypothesis? It's going to sort of sound like the reverse of the other one. I'm going to say there is a difference, but it dissolves faster in cold water. Now, is there a possibility of any other hypotheses? Sure, there always is. Another hypothesis is Alka-Seltzer doesn't dissolve in water. All right. Another hypothesis is Alka-Seltzer is way too expensive. I would never buy it. Another hypothesis is Alka-Seltzer doesn't work when I have a headache. But those are just silly questions. I mean, those are silly hypotheses. When we look at them, we will decide they don't really answer the question. They don't make sense. They're not valid. There are three hypotheses. One says there's no difference in the time to dissolve in warm and cold. One says there is a difference and it dissolves faster in warm. One says there is a difference and it dissolves faster in cold. And really, I mean, those three standard hypotheses are the ones we usually have when we have what is called a two-variable question, like the Alka-Seltzer one. So the research question, are cats smarter than dogs? Well, I'm going to make the research question a little bit better and say, is there a statistically significant difference? SSD is my abbreviation for statistically significant difference. Make a note, SSD stands for statistically significant difference, meaning we've used a statistical test and it's given us a result. Is there a statistically significant difference in the IQ of cats and dogs? So there's the null hypothesis, right? There is no statistically significant difference. Here's alternate one. There is a statistically significant difference in the IQ of cats and dogs have a higher IQ. Alternate two, there is a statistically significant difference in the IQ of cats and cats have a higher IQ. Is it possible there's another hypothesis? Of course, the answer is yes. There's always the possibility for other hypotheses. So alternate hypothesis says 3 is that generally dogs are bigger than cats. And I'm going to go, wait a minute, that's your hypothesis? Well, that doesn't seem valid to me. It doesn't even answer the question. I'm throwing it off the list. Oh, well, what about this one? Dogs make much better pets than cats. Sorry, that's not valid. It didn't answer the question. I'm throwing it off the list. Right? You see what I mean? Whenever we think about hypotheses, you have to account for the fact that when you make a list of hypotheses, there can be some horrible ones on it. But in this case, we've got these 3 standard hypotheses. One says there is no difference. One says there is a difference, and the difference looks like this. And one says there is a difference, and the difference looks like this, the opposite of it. Wow. Lots of stuff to think about hypotheses. Oh my gosh, there it is. I stuck one down there. Alternate hypothesis 3. Many people are allergic to cats, but few people are allergic to dogs. Does alternate hypothesis 3 get to stay on the list?
I would say no. Isn't all pet dander the same?
No, I don't know about that. I don't know. I've got dogs and I've got cats, but just look at the question. Remember, the research question is, are cats smarter than dogs? Does this hypothesis answer that question?
No.
Yeah, no, that's it. It didn't answer the question. And you may think, well, how did it even get on the list? But it happens. Hypotheses that are not good, they do sneak onto the lists pretty often. But then, how long did it take us to get this off the list and throw it in the trash? We just had to ask, is it valid? Does it answer the question? No. Well, goodbye then. It didn't answer the question. I mean, that's super important that it answer the question. That's why we have those tools. Right? Sorry. Is it valid? Is it testable? Is it falsifiable? I mean, those properties are, that's the easy way to get hypotheses off the list if they sneak on the list, but they're not really valid or testable. All right, so I'm on slide 16 now. I didn't really make that much progress, did I? But we looked at a number of really good examples, and that's great. Now, there's nothing preventing you, of course, from looking through the rest of this and thinking about it when it comes to the Alka-Seltzer experiment, which I'd like you to think about. All right. The next step we will do is we will generate predictions. I'm going to show you tomorrow exactly how to generate predictions. All right. But as far as today, so I like this one, no gas cap. Well, it's possible that could make an effect. I don't know. But, the bottom line is that, are you implying that my mom put sugar in my gas tank because I was rude to her? Oh my gosh.
Yes, I was.
Yeah.
Cause and effect. If she didn't like you.
My mom would do that. My mom would do that if I was rude to her. I'm never rude to my mom. She's 87 years old. I'm taking care of her during the COVID-19 situation, and I'd never be rude to her because she is vindictive, and she could possibly go ahead and do that. So where am I? I'm back here over at meeting. All right, so look, I'm going to go, I'm never going to look at characteristics of life today, though I am going to post that document. I'm back to the Alka-Seltzer lab, and I feel like we could move a little bit forward here. Oh, maybe not. We didn't really talk about these variables yet, so we'll do that tomorrow for sure. But then you could fill in part number 5 and write hypotheses, right? The null hypothesis and the 2 alternate hypotheses. You could do that. You could also, I suppose, based on what we've made decisions about up here. I mean, and I did notice that there was some dissent about me deciding to let everybody use to let people use different amounts of water. I mean, I note that dissent. I'm just worried a little bit about what containers people are going to use. And I'm worried that somebody may have such a small container that it almost fills 100 milliliters of water, almost fills it up. Or I'm worried they're going to use such a big container that 100 milliliters of water just barely covers the bottom. So I'm still wanting to leave that flexible. In the end, though, I would certainly consider listing that down here when it comes to weaknesses, in which you go, look, I actually think we should have used everybody should have used the exact same amount of water. Now, I'm not asking you to do this experiment yet. I don't want you to do this experiment yet. I don't want us to do this experiment until we have effectively filled in all of this. But you know what? This stuff here about variables, it's pretty interesting and important. And so I'm going to just go back. I'm not going to lecture anymore. I'm tired. My throat's hurting. I'm going to go back to this. And I have not ignored this. On slide number 20, there is a description of the variables that I have mentioned there. So would everybody take a look? And then you could even go on to slide 21, where it says a standard 2-variable question, relatively answers, standard 2-variable question, etc. And then look at all these questions that I generated that are nice standard 2 variable questions. And we will zoom through that. We will zoom through that next time pretty fast. In fact, I think there's an excellent chance that tomorrow I will ask people to actually conduct the Alka-Seltzer experiment. We'll take a break where people can do that at home. So if you can gather all this equipment together, that would be wonderful. And then we'll take a break, and then we'll have people gather data, and then we'll come back and we'll tabulate all that data, right? And more or less complete that. Oops, where did I go here? Okay, more or less complete that experiment. That's what I'd like to do. I mean, I know there's a lot of paperwork. It's like, let's just throw some, let's just throw some Alka-Seltzer in water. But I'd rather you didn't yet. And don't Google it. So Emily, I'm not gonna post the characteristics of life PowerPoint yet. But what I am gonna post as soon as we're done is I'm gonna post a document, a Word document called The Characteristics of Living Things. And if you wanted to look at that and review it and think about it, that would be wonderful. But here's what I really would like to ask everybody to do as homework, okay? I want you to look up the word life and tell me and write down a definition that you can share. It doesn't have to be a PhD dissertation, but you could share with the class tomorrow about what life is. So what we're from a biological perspective, I want people to do a little research a priori, that means ahead of time, about what life is. And it's going to be very easy. You're going to go to whatever search engine you use, Google, Firefox, Yahoo, whatever. And you're going to Google life, and you're going to find a definition of life that you like, that you feel like you understand, and you're going to write that down so that we can share it tomorrow, okay? Between now and then, I'll be working on finishing up that stuff, but I will post the characteristics of life today. And I'm also going to remind you that there's that quiz out there floating around, and I don't know, I got to ask, has anybody completed that quiz on D2L and sent it to me? Yes. And did it work? That's the real question. Did it seem to work? Yes. Well, so I don't know if that's an answer to yes. It worked. Oh my gosh, it's a miracle. I'm telling you, it's a miracle that I was able to figure out how to make it work based on somebody talking to me over the phone. So I am talking about quiz number 1. Kendall, there's a quiz already out there. It's quiz number 1. You missed the beginning of class, and you've got stuff that you need to do when you're going to need to go back and look at some of these pre-recorded lectures that I've already given. So you have got plenty of stuff to do for sure. But there's a quiz on Tuesday and Thursday for the next, really the next 4 weeks. That's this week, next week, the following week, there's quizzes on Tuesday and Thursday. And at least now, now that I've been able to set that quiz up in D2L, I suppose I could go back and make that a timed quiz. And I haven't even considered doing that yet. I'm amazed, Mike, that this quiz actually worked, right? So I'm pretty happy about that. I'm going to pat myself on the back. Good work, Steve. And so that does mean I'm moving in that good direction. So hopefully I can put other quizzes on there just like that. Now, one thing I am going to tell you, and this is critical, is that I'm going to post a key to that quiz so you can see key and use it as a study tool. I'm going to post that afternoon on Thursday. And look, if I don't have your quiz by then, because you procrastinated, right? I'm giving you 48 hours to work on this quiz. You procrastinated, then I'm not going to be able to accept it. And you understand why. I've just posted a key, or will have posted a key, which you could use to answer every question just fine. But I'm going to post a key so you have a written physical copy of the key that you can use as a study tool. Okay? And you know what? When I post keys, I usually put some bonus answers on them, which means that I will actually be providing some answers to thought questions for you that you could use as a study tool. Okay? So I'm happy to answer any last minute questions. Yes, Jade, thanks for asking. The grade will be entered in D2L. Right? So I'm going to post all grades in D2L. Have I posted any grades yet? No, I haven't, because I'm still working my way through what I would call a gigantic list of emails with lots of little documents that need to be looked at. But I will be posting all the grades on D2L for sure. Okay. Aside from the fact that that's required by PIMA, the bottom line is that under these circumstances, I don't know how else to provide you with grades. I guess I could call you. Okay, here's your grade, but now I'm going to be able to post it on D2L, and you'll only be able to see your own grades there, and that's great. I'm really helping people get good grades because they're putting up with me and all of this stuff. Okay? So okay, go ahead.
I'm a little confused on like priority of what I should work on first for due dates wise. So could you go over what's due when?
Sure.
Like, so
I am absolutely happy to. Let me just go here because this PowerPoint is got some of that stuff right here. So quiz one. Oh no. Today is day 4. Was yesterday day 4 too? No, yesterday was day 3. Sorry about that. So here's the bottom line. The metric measuring lab was technically due today at 5, but several people have emailed me and they're having problems with it. So look, if you were not able to get it to me by 5, get it to me as quickly as possible. But in terms of priorities, I think I would worry most about quiz 1 and getting it to me by noon on Thursday. Because once I've posted that key by noon on Thursday, I won't be able to accept it. Now, honestly, I'm thinking I'm giving you a pretty generous amount of time to get that quiz done. And you can either go on my PIMA and download the quiz and fill it in by hand and take a picture and send it to me as an email attachment. That would be fine. Or you can take it on D2L and then submit it on D2L, because I guess I've managed to somehow make that work. So I would say priority 1 would be to work on that quiz. Priority 2 would be doing the metric measuring lab and getting that turned in as soon as possible. Priority 3 would be to look at the sections of the Alka-Seltzer lab that you might be able to think about an answer now based on what we've learned since the last time. And then certainly a kind of a high priority, somewhere in line there, is the thought questions, because if you were thinking about the thought questions and even writing answers to the thought questions, that will help you do better on quizzes, okay? So it was a little vague there, but I was trying to be as specific as possible.
Okay, thanks.
Who was it who asked me that question?
Travis, me.
Travis, thank you, Travis. You know what, I mean, this is crazy. It's crazy that I'm not in a classroom where I can see people, and that makes me insane. Eventually, I will recognize people's voices, I'm sure. But being that I don't actually see you, it makes it so much harder. Okay, and then Catherine, it says, can you show us again on how to download quiz 1 from my PIMA? I am happy to do that. Okay, I'm going to reduce this back down again. I'm going to go to, let's see. it's possible that I may have to just log in again. I may just have to log in again, but that's okay. See, it's already sort of shut me off here. But I'm going to go through it real quickly because I'm sure if you have a question that, okay, thank you. If you have a question about it, and there are other people who have a question about it too. Okay, logging in, and then I'm going to, so this is the login page. One way to get the quiz is as simple as this. You go to My Courses, and it's logging that in. You go down to our link here for this is the class that we're in now, and you click on it. Now you're in what is sometimes referred to as our My Pima homepage. And there's a blurb I wrote, okay? And then go to Drive. There's Drive where all the folders and et cetera are held. And then we're going to go here to this only folder there that has 12 documents in it. It'll have more documents once I upload the characteristics of living things. And now you can actually look at that list. Now, I'm going to tell you, I'm usually going to front load quizzes, which means this says 003.quiz1. I'm going to try and front load quizzes and quiz keys, okay? So it'll be a little easier to find them. But once you're here, you can download multiple files. All right. I'm going to download the quiz right here and open it up. And there it is. Now, you could, I'm sure you're going to see just what I'm seeing now. You could enable editing. You could go in and fill in the answers and then save this as a document and then send it as an attachment in an email to me. That's one way to do it, and I'm totally fine with that. Okay, Catherine, did that answer your question about that? Hopefully she just chatted me. Yes, thank you, Steve. Anyway, then, but the other alternative is to go back to the home page where you first log in, and then you're going to go down here to D2L. Once you're on D2L, it's going to show us that beautiful forest. Reminds me a little bit of Mount Lemmon. You're going to click on that. That's going to take us to our D2L homepage. And then you go up here to assessments, go down to quizzes, and there, my page looks a little differently than yours. Your page will look like this. I'm logging in as a student now, and there I go to quiz 1. And there it is. And I don't understand this. I do not understand. But when you go to answer this question, it will show you the entire question, right? Okay. So there's more than one way to get to the quiz. And that means there's more than one way for me to grade the quiz. And that means that it's going to make me crazy, but that's okay. It's actually just going to make me a little crazier.
There's another way to do it. If you click on the course and then on the right, it'll say like one quiz unattempted. And then if you click on that and you press the quiz right there in the blue, it should bring it up like a full page in with everything on it.
Oh, okay, good. Now let's work our way through that again. You go to the course. Oh, sorry. Let me.
So, yeah, just go back all the way because it's like weird if you're already in it.
Right. Yeah, because it's better. We want to look at the very first page like this.
You can just press the home page. Okay, yeah. So where it says updates. Oh, sorry.
Okay. No, that's okay. No, I'm happy. All right. So here's our. We're going to go first here, right?
Yeah, that's just how I did it. So I just clicked on it, and then where it says updates, it said well, it won't say it for you, but it said it for me at least. It said like unattempted quiz, and then it just said 1 or something like that.
Oh,
I clicked on that, but I think if you go back to your assignments, I think there's another way to do it.
Go back to
Like the way you were doing it before. I think there's another way you can do it through that way.
right. Now I don't know. It's maybe up here. You mean where it says
It was like, it said quiz in the blue and then it said 1. I think if you just click on that, it should bring you to the same place I did.
Okay, and the reason it's on that student attachments, metric measuring.
Okay, maybe not. Or go under assessments and it'll say quizzes.
Okay, we go to quizzes.
And then press the blue quiz one where it's like highlighted in blue.
Right here?
Yeah.
Okay. And
it looks way different on my end.
There you go. It does, huh? That's crazy, huh? But there it is. There's a quiz. I mean, what I'm wanting to make sure is that people are able to access that quiz. And that's why, to be honest with you, I put it in 2 different places, because if you're sort of like me trying to maneuver and navigate through this, then I want it to be as easy as I can make it. Now, look, I think I'm going to get better and better at this. Okay. And, oh, I see. Yeah, it is set up for 1 attempt. But remember, this is open note, open book. So there's no time limit on it. You're going to just look at each question. And is it possible you could answer that question right off the top of your head? Sure. But it's open note, open book. There's no time limit on it now. And I'm assuming that with no time limit and open note, open book, people are going to be able to, they're going to be able to give really good answers on that very first attempt. Okay? All right. Well, it's 5:22, and I think I'm ready to stop doing anything and let you do your stuff. Okay? And that could be starting on the quiz, which I would normally do during class time, etc. But we will. So bottom line is that we're pretty much done for today. Now, Kendall, can you hang out? And I mean, I'm going to shut everything off. But what I'm going to do is then send you a new link for a meeting, okay? And it'll happen within minutes. All right? And so that's what I'm going to do. I'm going to send you a new meeting. Other than that, I think that we're done. I'm going to stop recording. And I'm going